NestJs is a framework for building scalable Node.js web applications with TypeScript. In this course, Vlad will teach you NestJs by teaching you how to build a REST API.
Hello and welcome to this course. My name is Vladimir. I am a full-stack software developer. In this course, we are going to build a CRUD REST API with NestJs. Our goal is to build something as close as possible to a production app. We will implement authentications, end-to-end tests, and we will work with relational databases as well as with a modern development ORM such as Prisma. My teaching style is very hands-on. I'm a firm believer that you only learn by doing. All my code is very easy to follow, but if you are stuck, you will find a GitHub repository with a completed project in the description below. Additionally, feel free to leave questions in the comment section or on my channel, Code with Vlad. I will try to answer to them as soon as I can. This course requires a basic understanding of JavaScript ES6 and TypeScript, but don't worry if you don't have it, as I will explain everything in a step-by-step fashion. So, what is NestJs? Not to be confused with Next.js, which is a front-end React framework. NestJs is a Node.js backend framework. It fully embraces TypeScript, and it solves a very different problem from, let's say, Express.js. It solves architecture, the weak point of Express.js. See, if you're using Express.js, it's very unopinionated. It doesn't give you a direction of how your project should be structured or how you should do things. And while Express.js can work out very fine for small projects, once your project starts to grow, and if you are not an experienced developer that knows how to structure it and scale it properly, it can quickly become a mess. But NestJs is not just another framework in the sense that it does not try to reinvent the wheel, it actually uses Express.js under the hood. So you can see it as an abstraction of Express.js. And in a nutshell, it allows to create testable, scalable, and easily maintainable applications. For NestJs, modularity is very important. It uses concepts like dependency injection, and it is often branded as the Angular for backend. So now that you have an idea of what NestJs is, why would you use it? Well, structure, modularity, native TypeScript support, a lot of functionality out of the box, easily integrates with GraphQL, microservices, REST API, and has very good documentation on security. It also tremendously grows in popularity, which is a very important factor to consider. In fact, right now, NestJs is the most popular backend framework, below Express, on the same level as Koa.js, and above Adonis, Loopback, Feather.js, and even Meteor. Plus, employers really love it because it brings architecture, structure, and it's easier to hire developers because they don't need to learn a new custom architecture every time they are onboarded on a Express.js project. So after that long explanation, let's jump into our project and code our NestJs application. And in this project, we are going to build a API, Application Programming Interface. This will be a CRUD API, which is a very common term for APIs, and the resources that we're going to either update, read, delete, or create will be bookmarks. So without further ado, let's get started. Before we start, we need to have Node.js installed. I'm using the version 16, but any future version with long-term support should work. You also need to have NestJs installed. So you need to install their CLI globally, NestJs CLI. Then we can jump into our terminal and create our new project with nest new, and let's name it NestJs API tutorial. The CLI will ask you to choose a package manager. I usually like to go ahead with Yarn. Perfect, now our project is installed. We can navigate into it. I will open it with Code, VS Code, but you can of course use any editor of your choice. And let me make the code bigger. This is VS Code, Visual Studio Code. The theme I'm using here is Material Theme, and the icons you see here is Material Icons. You can download them and install it here via their extension menu. So NestJs has created a starter project for us. It has a source folder where our files are. It has a test folder where it keeps the end-to-end tests, and it has some configuration files here. Let's first clean it up. We don't need the app controller spec, and we don't need the app.service. And nor do we need the app.controller. And since all those files were imported into the app module, we need to go and delete them here. So for Nest, modules are very important. You see that this file, the global file, is called app.module.ts. This is similar to something that we have in React, where we have an app.js or app.ts file. So this will be the main module of the app that will import other modules. So I have talked about modules, but I haven't introduced what is a module. So for any concept related to NestJs, you can just go into the NestJs documentation, and it's on the nestjs.com, and you click on documentation, and you'll have this page where you will have a lot of docs on any concept that you want. And for instance, here, module, it's written that it's a class annotated with the module decorator. And in fact, we have a class called app_module that has been annotated with the module decorator. If it's not annotated with the module decorator for NestJs, it's not a module. And if you don't know what a decorator is just a function that adds some metadata to the current class or function that it is kind of decorating. So it just adds more property to that class. So if we go back to the modules documentation, we see that a module can import other modules, and it is the case for the application module. So the main module, the root module, it can, for instance, import user module, orders module, chat module, any module that you want. And every module can itself import also controllers and providers. We are going to talk about those a bit later, but for now, know that a module can import other modules, and usually I like to organize my modules into feature modules. So if I have an application where, for instance, we have bookmarks, well, what would be the parts of the application, right? You will have the authentication logic where a user can create its profile, login, sign up. So for me, it will be Auth module. Then you will have maybe user module that will handle the logic related to the user. We'll have also the bookmarks module and maybe the database module. So you see, you organize your app into those features, right? And you break it down into modules. And the result is that it makes your app much more easier to handle and to reason about. Let me show you another project I'm working on just to illustrate the structure. So I have a source folder, and you see I have an Auth module, category, common, post, Prisma, which is a ORM for the database user. And if I click here, you see that you have some data, you have the module as we expect, and we have some providers. Those we are going to talk about it a bit later, but this is an example of a kind of production ready project. So you guys can see the organization and the code structure in a nutshell of NestJs projects. Okay, so we now know that modules organize your app, right? And they are declared with a class annotated by a decorator module. So let's go ahead and declare another class, another module, to break down our application into those small submodules. So we know that we are creating a bookmark application. What would there be in a bookmark application? Well, I have already touched upon the authentication. So in our CRUD API, I want to be able to create users and to allow them to log in, right? So we will have an authentication module. So let's go ahead and create a Auth module. And usually the convention is that you need to put the modules you create in a folder, and the only time that you can not respect this convention is when you're using the main app module component that will import all the other kind of modules or components. So let's go ahead and create the folder here, and let's name it Auth. And at first, I'm going to show you how to create it manually. When you're using a framework for the first time, it's better to actually write everything on your own and not use any generators, because NestJs has a generator, has a CLI command that allows you to kind of automate that creation. And we're going to see that in a moment. But at first, let's just write it by hand so we get a bit of a muscle memory going on. So we create a folder called Auth, right? What do we know about modules? We know that it should be a class that should be annotated by a decorator module. So let's create a file, and we just respect that convention that if we have a file, we try to add its kind of function to its extension. So this is an extension, right? .gs is an extension, .ts is an extension, .cpp for C++ would be an extension as well. So here, since it's a module, it will be auth.module.ts, and we are using TypeScript for all the projects, so it's ts. And we need to create a class, so it will be auth module, right? And we need to decorate it with a decorator called module, and that decorator comes from the NestJs common module, and we just need to open it, provide an object, and that's it. That's the minimum requirements to create a module. So all we need to do is to save, and that's it. We have created a module, and we have forgotten something important. We have forgotten to export that class. So if we don't type export, this class will be available only inside that module, only inside that file. We need to export it to allow other files of our application to use it. So we go back to app module, and now we can just import auth module, and we can use the TypeScript IntelliSense to help us to find our modules and files. So here it knows that the auth module exists inside auth. So all we need to do is to click here. If it doesn't appear, you can always do command dot or control dot, and it will propose you an option to import it from the auth module file. And here it is. To verify that our logic works, let's go ahead and launch our NestJs application. So the bootstrap logic is inside main.ts. It looks a bit like what we could expect from a Express.js application, right? So we have the app that is being instantiated here, and then we launch a server on port 3000. I will use port 3333 because usually the port 3000 is reserved for React in my development pipeline. So I prefer to use 3333. I save it, and now I open the terminal in the project. Let me clean that out, and all I need to do is I need to do yarn start dev, and all those scripts are actually defined here inside the package.json. We have start and we have start dev. So the reason why I'm using start dev and not start is because start dev will watch our files and recompile the code when needed. So if we do yarn start dev, it will launch NestJs, and we don't have any errors, which means that it's very good. Everything has compiled correctly. NestJs has generated a dist file, so a kind of output compiled JavaScript file from TypeScript. We don't need to really worry about it. It's just how NestJs works, and that's it. We have our API working. So let's clean that up and come back here. So modules allow us to break our app down into smaller components that we can easily manage. Let's go ahead and create the user module and the bookmark module. In this case, I'm going to use the Nest CLI to create those modules, so you have an idea about how it works. Just open the terminal, and we're going to open a new terminal session, and we execute nest g for generate module, and we name it user. And Nest will generate the module for us and automatically import it into the app.module for us. So we have a folder user with a user.module class here, and we do the same thing with a bookmark, right? And it also generates a bookmark module for us. And if we check our terminal, let's kill this one, we see that the application is still logging. If I, for instance, press Ctrl Save, you see that it is recompiled. So everything is working correctly. Now let's add more logic to our application. So let's add the login logic. So when we build a NestJs application, we usually separate our logic into controllers and service. We can refer to the documentation, and basically it says that controllers are responsible for handling incoming requests and returning responses for the clients. And providers or services are responsible for executing the business logic. So we separate our logic into controllers and service or providers to be able to simplify what we do, right? So let's go ahead and implement it. We go now into Auth module and we create a service and a controller. So again, the same can be done with the NestJs CLI, and we're going to do it by hand the first time. So let's create a controller, auth.controller.ts and auth.service.ts. If we go to auth.controller, we need to create a class authController. We need to annotate it with the decorator controller. So NestJs knows that it's a controller. And we need to do the same for auth.service. Class authService. For the service, we need to annotate it with the decorator injectable. And that just means that it's going to be able to use the dependency injection that NestJs uses under the hood. But more on that a bit later. And we need to, of course, export those, otherwise we will not be able to import those classes in our application. And since we have added it, we need to add that to the module as well. So controllers auth controller and providers auth.service. Let's check our application if it's running correctly. Okay, no errors. Cool, running good. So I've introduced the dependency injection, but I haven't really said what it is. You can of course Google it online, but let's go ahead and introduce it with a concrete example to see how it works. So we have a auth service class and we have a auth controller class, right? What is happening usually is that the controller will need to call the service. So the controller will receive a request from the internet, for instance, a post request asking to log in a user, right? And then it's going to call a function from the auth.service class and return its result back to the client, back to the browser. But to do so, auth controller will have to instantiate a auth service class, right? Because in the end, it's JavaScript. So if you want to create that instance, for instance, it would be service is equal new auth service, right? To avoid doing that, to avoid having to manage where it's created and who manages it all, we use dependency injection. That means that instead of our controller to actually have to declare it, for instance, to actually have to do something like that, give me the service here. Give me that an instance of that class, and I don't care how to instantiate it, just give me an instance. And this is how you do it in NestJs. Private auth service auth service. And that's it. NestJs will handle on itself how to instantiate the auth service and how to pass it to you in that auth controller file. So you don't need to really worry about. And private here, if you have never seen that notation, it just means that. And then have to do something like this auth service is equal auth service. Instead of doing that, you just write private and you scrap off this. That's just a shorthand. And if we check our code, we see that it is being executed. So everything is okay, everything is compiled. And now if we want, like if we put a function into the auth service called test, this function is not going to return anything. If we want, we can call this function directly like that, right? So that's dependency injection in a nutshell. If you want to have more information, just Google it. There's a plethora of explanations online how it really works. This is how NestJs uses it, and basically it allows us to not handle dependency management, and it's just easier to work with when we have dependency injection. So let's come back to the Auth service and create two functions, because our Auth module will manage two functionality, login and sign up. So let's go ahead and create a function login and sign up, right? And that's all it's going to do for now. The Auth service will store the business logic. Right now there's none. So let's come back to the auth.controller and create two endpoints, an endpoint for login and an endpoint for sign up. So the way to do it again is using decorators. It just simplifies how you write your logic. So we expect a post request on sign up and a post request on login. So we create a function, let's name it sign up, right? And sign in. And to make it a route, we just need to annotate it with a post decorator that comes from NestJs common, and let's call it sign up. And sign in. And since we are in the Auth controller, it's usually a good practice to put a global prefix route called Auth. So when we are going to call that route, we need to do a post request to Auth sign up, right? And if we call that route, it's going to be that request. Let's just return a string for now. I am sign up, and here I am signed in. Let's verify that the project is compiling, all good. And let's go ahead and test our API with Insomnia. So Insomnia is a HTTP client similar to Postman. You can also use Postman if you are used to it. Insomnia is just a bit more minimalistic and easier to use. So let's go ahead and test our endpoint. And if you remember, our Auth controller was on the endpoint Auth, sign up, and right. And we do the send request, and we see that we have response, right? I am sign up, and that is basically what we have written here, right? And if we launch and if we request sign in, it's going to print us the other response. One interesting thing though is that if we look at the headers, we see that it is powered by Express. So as I said it in the beginning, NestJs uses Express under the hood. You can replace it by another framework called Fastify, but for most use cases you will probably use Express, and that's going to be just fine. That also means that everything that you know about Express, you can access it. So this is a nice thing about NestJs. If you like Express.js and you need more structure in your app, you can use NestJs and still have access to that Express ecosystem if you need. One other thing that is very interesting is that Express has sent us a content type of text HTML, right? So this is a text. So NestJs will automatically convert the data type based on the return. So here it's a string. If I send a object, for instance, message hi or hello, and we send it to sign up, we now have a object, and the header is application.json. So that's very handy. You don't need to worry about sending the right data type. NestJs will do it for you. Let's go back to our app and let's create more logic. So as I said in the beginning, the controllers will handle the requests. So it will fetch the body of the request if needed. It might check some headers or any work related to the request. Regarding the business logic, the actual execution, we offload that to the service. Usually the pattern is that we are going to create the same function on the service side. So let's go ahead and do it. We have a function now, sign up and sign in, right? And instead of returning something from here, we can actually call the service, and we can put that message here, sign up, hello, and let's write I have signed up, and here I have signed in. Right, everything is correct. And let's call those functions from the service. This Auth service dot sign up, and this Auth service dot sign in. So what it does is that it allows to keep our controller clean and only busy with the logic related to the requests, while our service will be busy with the business logic, like connecting to the database, editing the fields, etc. So let's go ahead here and do it again, and we see that it works as well. And if we launch sign in here, it also works. Now we know how a controller works. We know that it is responsible for handling requests. We know how a service works, or a provider. It is responsible for handling the business logic. But what would be a business logic without connecting to a database, right? So we need to somehow set up a database and connect to it. And by that time, I guess you have noticed it, my style of teaching is to introduce concepts bit by bit. So now we need a database. Let's go ahead and set up a database. For that, we are going to use Docker. Docker is an amazing tool that will allow us to run our database directly on our computer, but so we don't have to install it. So it will run in a containerized environment. I have Docker already installed. You can go ahead and install it. And one quick way to check if it works, you just write docker ps, and if it inputs something, that means that it's working. My version is version 20. With that being said, let's go ahead and create our database. So when I work with databases, I prefer to use Docker Compose. Docker Compose will automatically allow me to spawn the Docker containers and to destroy them. So it's very handy. Let's go ahead and create docker-compose.yaml. So here's the configuration of our Docker Compose. I use version 3.8. In the services, we define our Docker container that we want to run. It's going to be devdb. This is just the name I give it to it. The image I'm using is Postgres 13. So we are going to use the relational database Postgres version 13. It's going to be exported on the port 5334. So if we connect to Postgres 5334 on our computer, we'll be able to access it. And the environment variables I'm going to use is the user rule is going to be Postgres, the password 123, as you have seen, very secure, and the database name will be Nest. And it's going to be on the network freeCodeCamp that is defined here. That's about it. So to launch our database, we go back to our terminal, we open a new one, and we do docker compose up. We choose the DB that we want to run, so it's devdb, and we will run it in background, so with D. And that's it. And if we go to docker ps, we see that we have a container now that is running, and we can even access a log if we want. So docker logs, and it's written that the database system is ready to accept connection. It has deployed, it has compiled, everything is running correctly. Cool. Let's go back to our app. So we have the database running in Docker, but how do we access that? There are libraries like SQLize, TypeORM, Mongoose that allow you to connect to the database. In this example, I'm going to use a new ORM that I really love and I have been using for over a year now. It's called Prisma. So you can access the website on prisma.io. What Prisma is in a nutshell is that it's kind of a query builder, but it's so easy to use. So basically you define a model. For instance, that will be a post with ID, title, and all the fields that you want in the database. And you can get them from your JavaScript code or your TypeScript with that syntax. And we're going to explore it straight away. So with Prisma, we are going to create the database connection logic, the database module in a way. So that means that we need to create another module, since the database module will be able to be used by Auth module, because you need to log in, sign up, It should be used by bookmark module and even by user module. So it's a new feature of our app. For Prisma, we need to have two libraries installed. The first one is the Prisma CLI. It will allow us to create our schema and run migrations, deploy the migrations into the database. So it's more of a maintenance library. And the other one is the Prisma client. So Prisma has different clients. The one we're going to use is for JavaScript. So let's install Prisma CLI, yarn add, and we're going to add it as a development package Prisma, and yarn add Prisma client for the client. Okay, let's clear that out. With that being installed, we now have access to the Prisma CLI. Let's run it. npx prisma init. And it's going to generate several files for us. First of all, it generated this .env file for the environment variables, and it just created a postgres connection string by default that we're going to change a bit later. And it also generated that Prisma folder in the root directory. So what it just has its schema, and this is where we're going to declare our models. See, when you use a library like type or rem, you will create entities and you will place them inside your logic. For Prisma, there's only one place that you need to handle your models, a bit like with GraphQL actually. So you would declare those structures that will describe the shape of the data that will be in your database, right? Here it says that it's going to use the Prisma client.js library, which we have installed. The provider will be Postgres, but you can have any other library. Prisma supports MySQL and even MongoDB. And the URL is the URL of the connection to the database. So it's going to grab it from the first environment file that it finds. So if you place one inside the Prisma folder, it will grab this one. For that tutorial, we're just going to leave it here in the global root folder, and let's go ahead and create our models. So the way to declare the models is just to type model and you name it with a singular word. So if it's users, it's going to be user. And if it's bookmark, it's going to be bookmark, right? Model, bookmark. And what do we have in our app? We have users and basically bookmarks, right? So we only have two entities in our app. So the user will have an ID field. It's an integer. We need to tell Prisma that it's an ID, and we need to set a default as auto increment. All that can be found in the Prisma documentation, of course, and same goes for bookmark. We also have to add the created at field, otherwise we will not know when it has been created. It's going to be a date time, and the default would be now, which means when the record is created in the database, a default value of now means the time at the creation is assigned to that variable. And we also have to add updated at. I like to add that as well, date time, and Prisma has a special command here, updated at, and we can copy that to the bookmarks as well, right? So for the user, what we will have? Well, usually we store the email of the user. It's going to be a string, and it's going to store also the password, at least the hash of the password. So we're going to put hash string. By the way, if one of the fields needs to be optional, you can just put the... So let's create two optional fields. First name is going to be an optional string, and last name optional string as well, right? We also have a bookmark. So the bookmark that we're going to save is going to have a title, is going to have a description, which could be optional, and we are going to have a link, which will be also a string, but will not be optional, because when you save a bookmark to a certain link, well, a link needs to be there. Here we go. We have created our two models. We save the file, and now you see it auto formats it nicely. Then we need to add the database connection string to our database URL variable here. So let's check it here. So the user is Postgres, the password is 123, and the database name is Nest. So let's go ahead and change that. user is postgres, password is 123, the port is at 5434, the database is nest, and schema public, we can leave it out like that. So now when we run Prisma commands, Prisma will be able to access our local database that is running here, docker ps. By the way, if you have the Docker app installed, like I have on Mac here, you can access the dashboard for Docker and see your container in action here, NestJs API tutorial, and you can even see the logs, right? So let's run our Prisma command. So the way to do it is to run npx prisma, and let's press help to get some help. So we have several commands. All that is explained into the Prisma documentation, of course. It's quite nice, by the way. You can check it out. So we have several commands that will be useful for us. We have a generate, we have a migrate, and we have a studio. Studio will allow to create a kind of a online client, so we can explore our database through the browser. We're going to see that soon. But the one that we are interested at that point is Prisma migrate dev. What it's going to do is that it's going to read that schema and it's going to generate the migrations in that folder. So let's go ahead and run that. Terminal, clear, npx, prisma, and migrate dev. And basically says that, you have added tables, bookmarks, and users. For those migrations to be applied, we need to reset the database. And it's usually common when you run migrate dev, it's only for development. If you need to push your migration to production, there's another command that will not delete the data. But for now, we can just delete it and we can press yes. And it's going to ask us the name of the migration. We can just say init. And now we see that it has generated a migrations folder, and basically it just generated some SQL. And when we run Prisma migrate dev, it actually does two other things. First of all, it pushes automatically that schema, that SQL to the database. So the database, if we go there and we check the logs, here we see that there's some command that has been run, insert into public users, created add, email hash. So Prisma has already pushed some migrations onto the database, so the database has the tables of users and bookmarks. And one other thing is that Prisma has also automatically run the generate command. So when you use Prisma migrate dev, Prisma also does npm prisma generate. And what generate does, and it's actually a very cool thing, is that it takes your schema here and it creates TypeScript types for your schema. So it creates the user interfaces or classes, and same for model, the bookmark interfaces or classes. So we can directly use those fields in our code. So we can go, and now we see that we have a user here, the user and the bookmarks as well that are exportable as TypeScript types from the Prisma client. So we can use those types directly in our application, which is awesome, which is very awesome. We don't need to code that by hand, we can use it directly with Prisma, right? So let's come back to the schema and inspect our database with Prisma Studio. So Prisma gives us a very handy tool called Prisma Studio. We can execute it by typing npx prisma studio, and it's going to connect to the database at the URL in the env file. Here we go, at port 5555. We are now at the Prisma client, and we see that we have a user and a bookmark models, right? And we can go here and inspect our database when we'll have some stuff there, and we can even add records if we want. So it's totally compatible with the Prisma schema. It's actually quite cool. Let's discard the changes for now and come back to our code. We can leave that running, that Prisma Studio running, and we can come back to our code here. So far we have created the Prisma kinda migrations folder, and we have created the Prisma schema, but we don't have any way from our code to actually connect to the database. And for that we're going to create a module to do it easily, right? We're going to encapsulate all our logic regarding the database in the module and only export from the module the stuff that we need to be accessed by the application, right? Let's go ahead and create a module. I'm going to use the Nest CLI because I'll be quite lazy here. Module Prisma, and I'll just call it the same name as this folder, but it's of course two different things. Here, this Prisma folder in the root stores the schema and the migrations, while this one will be our module following the NestJs modular structure, right? So we will create NestJ module Prisma, and now it's here. And we will also create the service. We have created the service manually here. Let's go ahead and create the service with the CLI. So instead of module, we have Prisma. We have service. And by default, it is going to create the spec files, so the test files. We don't want that here, so we say no spec. And now we have the service that is imported as provider in the module, right? And in the service, we are going to create our logic that connects to the database. So the way I like to do it is that I like to have the Prisma service extending the Prisma client. And Prisma client is a class that allows to connect basically to a database, right? It has a constructor, it has connect, disconnect, and execute SQL and everything. So what I want to do is I want to instantiate it with its configuration. So I need a constructor and I need to call super. So super will call the constructor of the class I'm extending, and the constructor of Prisma client needs to have data sources, needs to have DB and URL, and the URL will point to that string. In a moment, we're going to see how to use config variables, so dotenv and everything in NestJs. But for now, let's just put that hard-coded into our Prisma service, right? And I think that from now, we're going to need a bit of more real estate to run our scripts. So instead of running every time the terminal here, I'm going to kill it, actually Prisma Studio as well. And I'm going to run my scripts in a dedicated terminal. Let me make it a bit bigger. So I'm going to do yarn start dev, and I'm going to split it and do yarn npx Prisma Studio. And this is iterm2, of course. It's a nice terminal I use on Mac. So if you have any questions regarding the terminal, that's the one. Let's go back to our code. We have the Prisma service declared here, and we have it imported into the module. So technically how it works in NestJs. So let's say we want Auth module to have access to the Prisma module because it's all modular, right? Well, you would do something like import Prisma module, right? So let's see if that works, all works. And normally you would have access to the providers that are inside that module, right? So let's go ahead and try it out. So in Auth service, that is part of the Auth module, and that has access to the Prisma module now because Auth module imports it. In Auth service, we can use dependency injection to get reference to that service, to that Prisma service from our Auth service code. So constructor private Prisma, and we can just reference it by Prisma service. Let's press save and let's see what we have. Oh, we have an error. Well, why do we have an error? It says that Nest can resolve dependency of Auth service. Please make sure that the argument Prisma service at index 0 is available. So what it does is that it says, hey, you are trying to import a service here, and I don't know what is that. I don't have access to that. And even though we have imported the Prisma module from the in the Auth module, we have not allowed the Prisma module to export it to export the Prisma service to other providers. So if we want to do that, we just need to do exports Prisma service, right? And now the error should be resolved, and we don't have any error right now. So basically that means that if you have a module here, you will need to import it in Auth module to make it work. But that's a bit tedious because we have our Prisma module. Well, the user will need to have access to the database. The bookmark will need to have access to the database. And if we add 2 other modules, they will all need to have access to that Prisma module. So do we need to really import that every time? Like every time we need to create an import and Prisma module? No. What is possible in NestJs is to create a global module. So instead of importing it like that, what we can do, we can go into Prisma module and add another decorator called global. And just by adding that and making sure that the stuff that we want to be exported, it is also in the exports array, just by writing that, this Prisma service will be available to all the modules in our app. And if we check our logging, everything works correctly. Just make sure that your global module is also imported into the app module, into the root module, and in fact it is imported here. Now we can freely go and do what we want. And here comes the interesting part, because this is where we really start to write business logic. This is where we really start to do programming and not configuration. And if it was a bit tedious to set all this up, well, if you do something like that properly with Express alone, it will take you much more time, and you need to be really good with architecture to be able to make everything work flawlessly. Here in NestJs, we have everything working out of the box, and of course it takes a bit of time to get used to the way of NestJs, but in a long term it's going to save you so much time. And here we don't actually need the object, so we can delete it. The injectable can accept other objects, but for now it's not important in the scope of this tutorial. So without further ado, let's go ahead and start writing our logic. So for this sign up, what do we need? The sign up is the creation of a user, right? We need to create a user based on something that we pass in the body usually. So usually it's going to be a post route to Auth sign up. We are going to send a body to that route, and the body will contain the email and the password, and is going to receive something back. About something back, we're going to discuss more into details because we are going to touch to authentication and especially JWT, JSON Web Tokens. We're going to talk about that a bit later. Right now, just let's focus on the process between the request and what is happening in the logic. So NestJs has a lot of decorators. So this is a decorator. This is a decorator, right? It has a lot of decorators that have different functionalities. Remember I said that under the hood is Express.js. Well, if you want, you can access that Express.js under the hood. All you need to do is write a decorator called rec, and it comes from NestJs common, and let's call it rec, and we give it a type of request, which comes from Express actually. So you need to be a bit careful about that, where things come from. And if we now console log rec, we will see that rec will have a lot of properties, and those properties are actually coming from the Express request object. So let's just log it for the loads and call the Auth sign up. I have signed up, amazing. Let's go back to our logs here, and we see that we have logged the request object. And that request object is basically the same as the Express request object. And you can get stuff like headers, like body, etc. right? So if we wanna log the body, it will be something like request body. And then if we want, we can pass that body to the signup function. So let's go ahead and request the body and provide the body. Of course, it's going to be form URL encoded. here we have an email and a password. Let's send it over and let's log that into the console. And we see that the body has been logged. Now, usually how it would work is that we will pass the request body inside our function. And of course, here it complains because the sign up doesn't have any declared parameters. But what happens if the email is not defined, if the password is too weak, or even there's no password? Well, this process of validating that is called the validation. And NestJs has a lot of tools for that to make it really easy to do. But before even going to that direction, I want to point out that this method is not very clean. Every time we need to get a request and then we don't have any information of what is inside the body. NestJs uses DTOs, data transfer objects. In a nutshell, it's just an object where you push your data from, let's say, a request. And you can run validation on it if you want, and you can even have the shape of those DTOs because we use TypeScript. So we can say that the body should have an email and it should have a password, right? So let's go ahead and implement that. When working with NestJs, you should never really use the request object of the underlying library, because what if you switch to Fastify? What if you switch to another framework that they might add in the future? You will use that kind of independence that NestJs has. You will not be able to reuse the same code pretty much. So what we're going to do is that we're going to use another decorator called body, and it just allows us to get the body of the request, right? Let's call it DTO, and let's declare it as any, because right now we don't know the shape of it. And let's console log that DTO. And I'm going to use my favorite logging pattern. So basically it's just going to create an object and put the DTO inside it. And that's a shorthand for that. Let's go ahead and do the request again. And you see that it also works. So the advantage of using decorators like that is that Express will get the right body depending on the framework for you. So you don't need to really worry where the body is in Express or Fastify or any other framework. NestJs does it for you, right? But here it only brings us half of the answer because we don't know the shape of it. So we need to create a interface for that shape. Let's go ahead and create it. So usually I like to create a folder called DTO, and inside the DTO I use the baran export pattern. So I have an index.ts that is going to export all the fields. So here we are going to do what? Well, let's call it auth.dto.ts, and it's going to be interface called auth.dto. It will have an email, which will be a string, and it will have a password, which will be a string. And we need to export that. All right, we need to close that, and we go into index, and we need to export that DTO from the index. And if you have never seen that pattern, the baran export pattern, the main advantage is that now I can just do auth.dto, and it's going to import all the DTOs from that folder instead of doing something like auth.dto.ts, and if we have something else like signup.dto.ts, instead of doing that, it's going to import everything from the same folder. All the imports will basically be there in those brackets instead of being spread out in your code, right? So that's a nice pattern that I love using. It brings a bit of more code, but honestly, it's worth it. It makes your code much readable. And now we have access to those parameters, email and a password in the DTO, right? And let's clean it a bit, delete the requests. Here we go. Let's try it again. And it works again. But here it's only TypeScript. So what if we don't pass the email? What if we forget to pass the value to the email? Well, if we log that, we don't have any errors. We have email that is void and we have a password. So that's a problem because now we need to write codes like that. If dto.email, if not, then throw error. And this is very verbose. we can simplify that a bit by using the class transformer and class validator libraries. So let's go ahead and implement them. And just before we implement them, let me introduce pipes. What are pipes? In NestJs, pipes are just functions that transform your data. So if you have a string that comes from the request, because usually apart from if you send a JSON, if you send a string in a query, something like sign up, for instance, user is equal 1 or user 1, that 1 will be a string, and if in your code you need to use a number, that could be a problem. So one way of doing that is to use the built-in pipes. So what we can do is that we say email is going to be a string, and we can isolate the email field directly from the body like that. And the password will be created like that, right? And let's log those, email, password. And for some reason my prettier is not working. See, this line is a bit big, so I'm going to go into prettier and reduce a bit the print width. I need to try that out. Okay, 50 works well. And let's also log the type of email, which will type of email, and same for type of password. So again, I go here and we see that the email is a string, the password is a string. So what if we want to transform the password into a number? Well, it could be done simply like that by using inline pipes, parse int pipe. And there are other pipes, but usually it's this one that you're going to use. And here, since it's not a number, the password will throw an error. So it's going to stop the execution of our code. And if we check here, there's no console log. It's going to stop the execution of our code before even we run the business logics. So this is amazing. But if the password is a number, well, it's going to work right now. And we see that here, the password has been converted by the pipe to the number. Obviously, this process is a bit verbose because you need to create a pipe for every data field. What we can do with the DTO is just apply those transformation and validation directly on the DTO. Right? So let's go ahead and continue what we were doing with that small explanation about what are pipes. But I think it's quite important to understand the pipes before we move into the DTO validation. So there's more explanations about pipes on the NestJs website, and you see that we have different pipes: bool pipe, float pipe, UUID, which stands for unique identifier. But there's something called class validator. So basically, this is what we need. We need to install those two packages, class validator and class transformer. So let's go ahead and add them. Yarn add class validator and class transformer. Here we go. And now what we can do is that we can go into the DTO, and to apply the transformation and the validations, we need to use a class, not an interface. Basically, it is the same for us. It doesn't change anything. It's just that instead of interface, it's a class, and we need to add something here. Is email, for instance, from the class validator package, and is not empty. And it's going to be, and this is going to be is string, and it's going to be is not empty. And let's go ahead and throw the request again. And we see that it does not work, right? Why doesn't it work? Well, simply because we don't tell NestJs to use the pipe logic, to use the validation pipe globally everywhere. So we need to go into the main.ts, and just before the app.listen, write app use global pipes. And here we just write validation pipe. And validation pipe is a built-in pipe by NestJs for that same purpose, right? And we need to instantiate it like that, new validation pipe. So now that we have added that validation pipe, let's go back to the Insomnia and run the request. And here we see that we have two errors. The first one is email should not be empty and email must be an email, right? So that's cool. So if we provide something like test, well, it's still going to complain that it must be an email. So vlad@gmail.com, and now everything works. This is validation in a nutshell, thanks to dtos. The validation pipe can do other stuff, such as transform automatically your data. One thing that could be interesting for you guys is to see that use case. So if I'm going to my controller and I'm going to console log the DTO, right? And if I'm going to execute that logic, we log that. But what if I try to cheat? What if I have identified maybe a vulnerability in your server and I want to inject a variable, for instance, ID is equal 1 or any other variable? Well, if I console log, that ID will be passed to our DTO, and maybe that's not something that we want, right? One other thing that the pipe validator can do is that it can strip out the fields that you don't need. What we can do is just set whitelist to true. And it's going to do, right, we send the same request. And now we see that the ID is not here. What it is doing is that it's stripping out the elements that are not defined into our DTO. So now we can be sure that our DTO has an email and a password and no other fields that we haven't defined. So this is amazing. Let's go back to our controller now and write the rest of our logic. Now we know that the DTO is validated and it has an email and a password. Let's pass it to the signup function to make it all clear. Clean that. And let's open the auth.service. And in the auth.service, here the signup function will receive a DTO of auth.dto, right? And now we can run our business logic with self-assurance that the data that we receive from the client, from the browser, is actually correct. So the first thing that we're going to do is that we need to generate a hash based on the password. I like to use argon. So a lot of people use bcrypt for password hashing, and that's a fine solution. But I also hash the refresh token in my application. And there's a problem with bcrypt because its verification algorithm is only limited to the first 72 bytes. Argon is considered to be a better solution overall, so I'm going to go ahead and use argon. For that, we need to install argon 2. And we can import it into our auth service. So all as argon from argon 2. And the first thing is that we need to generate the password, then save the new user in the DB, right? And we need to return the user, the saved user. We're going to do those three things first. So let's generate the password. Hash is equal argon hash. The first will come the plain text that we wanna hash. So it's going to be dto.password, and that's it. Then we're going to save the user in the database. So const user is equal await, and it will be an async function, of course, because it calls Prisma asynchronously. This Prisma user, and since we have defined user in our Prisma model, create data, and this is the data that we're going to use to create the user with. And what do we have here? We have email, which can be dto.email, and we have hash, which will be that hash, right? We can save it, and it's not happy because it says promise string is not assignable to type string, and of course argon hash is an async function, so await. And the user is created, and then the user is created, we just return the user. Let's let's go ahead and create our user. So we can go back to Insomnia, delete that ID, and create the user. And our user has been created. Obviously, we see that we have returned a hash, which you should not return because that's basically the hashed password of the user. Not very secure. And let's try it out again. So we go to Prisma Studio. We can reload and we see that the user has appeared here. We can delete it, delete record, here we go, and go back to our code and just say that, listen, I don't wanna return the hash. Well, how do I do it with Prisma? Well, Prisma has a lot of possibilities. Either you create a select and you select only the field that you want. For instance, if we want only the ID, we say ID true, email true, and for instance, created add to true. So it will only return those fields like that. And let's go ahead and delete that. But obviously it's not very handy because there's a lot of logic to write, right? So what I prefer to do is to write transformers. So we're going to cover that topic a bit later, but for now, an easy and dirty solution would be to do delete user hash. So it's going to just strip out the hash out of that user object and return that. So let's go ahead and create one. And we have the user object without the hash. Amazing, right? So one other thing that will be interesting, what happens if I send the user again? Well, if I do it again, it's going to be created again and another user and another user. That's because email field is not set as unique in the Prisma. So let's go ahead and run the migrations to set it unique. And we can delete that, otherwise we will have some problems. And let's go ahead and let's get back to the Prisma model. And this is how migrations of Prisma work. So those migrations have created the bookmark and the user. Now we're going to modify our model and to make it all compatible with our database, so we can simply include the new updates to our database. What we need to do is we need to modify our schema. So for instance, email should be unique. We might want to rename the table user to users, because right now it is created user. It's good for Prisma because Prisma loves those kind of things, but we're going to just map this name to another name. So map users and map bookmarks. Everything seems to be correct. Amazing. One thing that we might add as well is the relation between bookmarks and user. So bookmarks will belong to the user. The way to do it with Prisma is to create a link to the user in the bookmark, because many to one connection. So many bookmarks can belong to the same user. In other words, this user can have many bookmarks, but any given bookmark at any given time belongs only to the one user and not to several users. So many to one. Let's create a user ID variable. It shall be an int, and user, it shall refer to the user model. We need to tell it it's a relationship. It's going to use fields. So we use fields to indicate to Prisma which fields are used for primary keys, and we use reference to indicate to Prisma to which variable this primary key references to. So it's going to be to the ID, which is an integer of user. So we just name ID, right? Amazing, right? So we have made some changes, and Prisma automatically included an array bookmark here. We just need to change it, bookmarks, and it's going to be an array of bookmark model. All good. So now we have made our changes. We need to run the migrations. How to do it? We come back to the terminal and we do npm prisma migrate dev. It's going to connect to the database, enter the name for the new migrations. Let's just name update models. It has run the generate, so it has generates the new variables in TypeScript for bookmarks and for user ID. and it has made the email unique. And it also has pushed the new migrations here into the database. And we might need to restart Studio. Sometimes it's a bit buggy when you run the migrations. And it works correctly. So now we have the user, and with the new fields, email should be, I believe it should be unique. Somewhere it should be written unique. But anyway, we have bookmarks here. And the bookmark has been updated with user ID and the user object, so which is really nice. Let's go back to our code and continue writing our logic. So we go back to the auth.service. Let's see if our logic against the duplicate user works. So we create one user, ID 1, because we have reset the database. And if we create the same user with the same email again, what we have is a 500. Not very cool, right? Because 500 errors don't tell us anything about what happened. It's better that we provide to the user a kind of a specified error saying, look, in that case, it is a forbidden exception because credentials is already taken, right? So we need to create that error. In NestJs, it's actually quite easy to do. And if you see here in the logs, we see that there's an error with the unique constraint failed on field's email. So Prisma tells us that email is unique and we cannot really use it. So what we can do is that we can add try catch block. So we put all that into the try catch error. Here we can just isolate if the error comes from Prisma or not. So if error instance of Prisma known client request error, and all that is detailed in the docs, right? The only time where you would write those detailed error exceptions is basically when you create unique field with unique properties. Basically, you don't need to cache all the possible Prisma errors. Here I just want to make sure that if I'm caching the Prisma duplicate unique duplicate error. So if the error is a Prisma error and not something else, if that happens, if error.code is equal to P2002, which stands for duplicate field, like Prisma has error codes defined, and this specific code stands for you try to create a new record with a unique field that has been violated. So if that happens, we throw a NestJs exception, throw new forbidden exception. Credentials taken, right? And that new forbidden exception actually comes from NestJs. It is well documented in the docs. And if the error does not come from the Prisma, what we do is that we just throw the error, right? And let's go back to our Insomnia, send the request, and here we see that the status code is 403, and we have a descriptive message, error message, telling to the client, hey, the credentials are taken, you cannot use that. Amazing, right? So we have created the signup service function. So let's go ahead and create the sign in. So what happens when we sign in? Well, the user will provide the password and the email. The first thing is that we need to find the user by email. If user does not exist, throw exception. Then compare passwords. And if password incorrect, we throw an exception. And if everything goes well, we just send back the user. Okay, so the sign-in function will also receive the same DTO as the sign-up. We don't really have a difference between the sign-in and sign-up process. In some application, they do. In some application, the sign-up object, the sign-up DTO will be more complex. But in our case, it's going to be the same. So the first thing is to find the user. So we go and find the user. Const user is equal await this Prisma user find. So the way you can find elements in Prisma, either you find them by find unique or find first. So if you want to find a single element from the database using Prisma, you can either find it with unique or first. Find first will allow you to get the element by any field, and find unique will allow you to get the element by unique field. So in our case, either a ID or a field with unique property. So let's use find unique, where email is dto.email, right? So the first thing that could happen is that someone tries to log in with an email that does not exist in our database. So to handle that use case, we're going to create what's called a guard condition. So if not user, we're going to stop the code at that point and throw an exception. Throw new forbidden exception, credentials incorrect. And if the user has been found, we can just continue our logic and compare the passwords. For the password comparison, we're going to use the compare function of the argon. So for the compare password, pw matches is equal await argon, verify. The first argument will be the hash, so the hash password. It is in the user, of course, so user.hash. And the second argument is the password in plain text, and it comes from the dto.password here. And again, we put a guard condition if not pw matches, if password does not match, we fire an exception, the same exception as above. Here we go. And if everything goes according to plan, we can send back the user. And before sending back the user, we can delete the hash field on the user object. That looks good. Now, before we go ahead and try it out, let's create some handy scripts for us. So first of all, let's just write a script that will allow us to respawn our database instead of typing it manually here in the terminal. Let's create a script in the package.json so we can just run it and it will rebuild our container for us, so our Postgres database. And the second thing is that let's also write a script that will allow to apply those migrations to the database. So let's start by the database. So let's call the script db dev restart. So that means restart the database with the dev development environment. So by definition, we only are in development, but if you have a project and that has several environments, such as testing environment, maybe staging or something else, well, you can create several scripts with that syntax. So for now, let's go ahead and first try it out our script here. So docker compose. So to remove a container, and here in our docker compose, our container, our service is called devdb. To remove it, we use rm, and let's go ahead and see what functionalities we have here. So we have force to remove them without asking us for a confirmation. We also have stop to try to stop the containers before removing them. It could be nice. It's a nicer way of stopping them instead of just killing them. And we also have this v to remove the volumes attached to that containers. And that's a good thing to do. So for our cleaning script, it's going to be docker compose remove devdb sfv. So let's go ahead and put that into our, maybe let's do something like that. Let's split our logic into several subscripts so it's just easier to manage. db dev rm, right? And the same would be db dev up, but instead of removing, it's going to push it to create it, and it's going to be done in background. And for the db dev restart script, it's going to do yarn db dev rm and yarn db dev up. Let's try our newly created script in our terminal and see if everything works correctly. Yarn db dev restart. So we see that it runs the first one and then it runs the second one. So we have the remove thing here, and we have the creation of the new Docker container here. And if we do docker ps, we see that we have one created here for us. The problem though is that even though we have created the database, it doesn't have migrations applied to it. So it does not have tables of users and bookmarks. So we also need to create a script to automatically apply the migrations. So remember, in the beginning, we have run the command Prisma migrate dev. What it's going to do is that it's going to generate a new migration based on the current migrations. And we don't really want to do that. What we want to do is that we want to apply those existing migrations to the database. So that process is much more safer than regenerating the whole migrations every time. Additionally, when you do Prisma migrate dev, it asks you for confirmation, and it asks you for a name of that migration. For instance, we have init here and we have update models. So it's very hard to automate. However, the other script that Prisma has is called npx Prisma. Actually, let's go ahead and check the migrate docs help. And we have migrate dev. That's the one that we have used in the beginning to generate the initial schema and to run the migrations. But if we just need to apply the migrations to a database, we can just run Prisma migrate deploy. So let's go ahead and create that script. So Prisma dev deploy. So it's going to deploy the migration to our dev DB, which is here at that link. So Prisma migrate deploy, right? So, and what we're going to do is that as soon as the database is up, we're going to run that script as well. So it's going to also deploy our current migrations to the database that we're working with, and yarn Prisma dev db. What might happen as well is that if you have a slow computer, the database might take a bit of time to start. So it's usually nice to put this bit of sleep here. I'll put sleep 1 second. So we are sure that before trying to apply those migrations, our database is running and everything is set up correctly. So we don't try to apply the migrations on a database that is in bootstrap mode. So let's go ahead and try that out. Again, yarn db restart. It's killing the database, it's restarting it, it's waiting a bit, and it applies the migrations here. And we see that it's written that we have found 2 migrations, and the following migrations have been applied here. Amazing. Now we can go ahead and start our server. And thanks to TypeScript, we now know that we have an error. Amazing. We don't need to run the script at runtime to notice that we have an error. We have it here even before starting the server. So we have what? We have in the Auth controller, you have not given a DTO, while in the service, you require a DTO. Let's change that. So in the service, the sign-in function, it requires a DTO, while in the controller, you don't pass it. So let's copy the body here, the body logic, and pass a DTO to the sign-in function. That should resolve the issue. Amazing. Now we can come back to Insomnia. By the way, I noticed how to make the font bigger. I don't know, I just didn't think about it. But yeah, basically there's an option in the general options where you can resize the font. So sorry for the smaller fonts in the beginning. I'm learning as well. Let's go ahead then and do the sign up request. So let's send it. And we had the user. If we try it again, we receive an error. And if we do sign in and provide the same credentials, we have the user again. If we do a mistake with the password, we have an error, which is nice. And if we do a mistake with the email, we have an error as well. Amazing. We basically have implemented the sign-in function and everything works correctly. One thing though, in real applications, when you sign in, of course, this information can be sent to the browser, so it can, for instance, render information about the user, but it is not enough to help the API, to help the server to actually identify the user connecting to it. We see that in our case, we send the email and the password, and it's called basic authentication, but we cannot do that every time, right? So there are some APIs where you need to send the email and the password and basically anything required by the basic authentication at every API request, encoded maybe in a base64 format. That might be a bit technical, but that exists. But in our case, for the user experience, we want the user to log in only once in a while, right? So to allow the server to track the user, to know who the user is, there are two techniques. The first is sessions. You probably have heard about them already. And the second one is GWT, JSON Web Tokens. And that's another way of tracking the user on the website. So know who the user is and allow or forbid the request based on user identity. Because if the user sends that back, it's not enough, of course. Anyone can fake that. This whole process is called authentication and authorization, right? So we authentify the user. So the user provides some credentials. We know who that is. We authentify then the user, but then we need to give something to the user so we can authorize that user through subsequent requests. For instance, login, sign up, everyone can call that route, right? But there might be something private, for instance, user/me, and that only authentified users can call it. So let's go ahead and implement that functionality. As I've said before, we are going to use GWT. For that, we have already prepared modules for NestJs. Now, so far, we only have seen custom-made modules. So it's modules that we have made ourselves. But NestJs also has modules that you can use in your app, like any NPM library. So let's go ahead and implement some of them. The first module that we're going to implement is the config module. So for now, we have used hard-coded environment variables. So this database URL, we have actually hard-coded it in Prisma, right? So instead of doing something like that, which is not secure at all because that will be available in your GitHub repository, and also it is error prone because what happens if you do an error here, right? It's very hard to notice and it can be only detected at runtime efficiently. So that's something that we're going to fix with the config module. So let's go ahead and install it. We can kill the server and install yarn add NestJs config. And we can start the server back again, and let's go ahead and implement that config module. So the config module is usually implemented on the root module, so here, or you can put it in a custom module and implement it there if you need to use something like validation on that. So for instance, you can check that, oh, this variable should be a string, this variable should be a number. This can also be checked, but it's out of the scope of this project, so let's just leave it out. But know that you can actually put the config module inside a custom module called config if you want. But for now, we're going to just import it here. We have just installed the config module. Let's go ahead and implement it. Config module, and you see it comes from NestJs config. I actually like to move all the node modules packages on top. Now config module requires some configuration, and if we and it requires a for root option. And that's all we need to do to load that .env file into our application. Under the hood, the config module uses .env library. I actually have a nice video about .env on my channel, so if you are curious how it works, check it out. Like any module that we have here, it also have a service, and that also uses dependency injection. So we can import that config service inside any of our modules of our app. So where do we need it? Well, at first we're going to need it in Prisma. So let's go ahead and use it in Prisma. To use dependency injection, don't forget to annotate a class with the injectable decorator. So if it has injectable, that would be able to use dependency injection. You don't need to put injectable if you don't have any dependency injection requirements. So if you don't use something like Prisma service, for instance, if you use that, NestJs will complain somewhere. For instance, Prisma user find many. If we do that, it should complain because it's going to try to get that object, and that will be undefined. So it will not know what the user is. And in fact, it says cannot read property of undefined, right? So for any class in NestJs to use dependency injection, and that class of course needs to be inside the module, we need to annotate it with injectable decorator. So now it will work. But of course, we don't want to use Prisma. That was an example. What we want to use, however, is the config module. So let's go ahead and name it config service. Config service is a service declared in the config module that we have imported it here. I'm just repeating it so you guys can absorb the new concept easier, right? Repetition is key. And what I'm going to do here is that this string now, I'm not going to hard code it. I'm going to import it from the .env file. And the way the config module exposes that .env file content is by having getters on the config object. So this is a config object. We can do config.get, and we just name the name of the variable and database URL. Let's put it in quotes, clean that, and fire it up. And now we have an error saying basically that, okay, we know what a config module is, but the config service is not exposed. Well, that happens because by default, all the modules are kinda contained. So this config module would be only available in the app module, but will not be available into the Prisma module. So it's very similar to what we have here. With global, you can expose our Prisma module to the whole app, while any NestJs compatible module also have this functionality. Of course, we cannot use the decorator here, but inside this object, there's an option called isGlobal. So we can just enable it. And that basically does the same thing. Let's come back, and now it should work. To make sure that our Prisma service is working correctly with config, we can go ahead and print the config. And we see that we get the right URL, so everything is working. And let's test it out. Let's create a new user. Vlad2. Amazing, the new user has been created, and that proves that our logic works. Now let's come back to the GWT. The subject of authentication seems to be quite easy, right? Like, how hard can it be? You just log in and sign up. Come on, every website has that. But in fact, under the hood, it's very, very complex, and there are companies, multi-billion companies, if I'm not mistaken, making hundreds of millions of revenues per year, providing that service to corporate and companies. So that's a quite edgy subject. To get it right is also very hard. So in this example, I'm going to provide a very simplified functionality, very simplified authentication. If you need to get more information about that, I have a 2 hours video on that subject alone on my YouTube channel. It's about NestJs GWT authentication. If you're interested, check it out. But without further ado, let's get started and dive in and try to add authentication to our CRUD app. NestJs has some decent documentation on authentication and authorization, and behind the hood it uses Passport. Passport is a authentication framework for Express.js with a lot of strategies. So you can log in with Facebook, log in with Google, Auth0, Twitter, GWT, and has a lot of functionality that you can use in our app. In our example, we are just going to use GWT. So basically the user will give the email password pair and it will receive a GWT. What is a GWT? I have a video on that on my channel, but basically it's just a string with a signature, some data, and some description about the kind of string it is and which algorithm it is using. And basically inside it is a JSON that is encoded in base 64, and this is the information that the server could pass to the client. So for instance, in our case, we could pass that the sub, which refers to the ID, will be an ID of the user. The name could be Vladimir in my case, and the email could be vlad@gmail.com. And you can add as many claims as you want. So all those fields are called claims. There's the expiration. You can put an expiration. We can put a creation date. Basically, yeah, you can put any data you want. And you pass that, the server creates that when the user logs in or signs up, and it passes it back to the browser. So every time the browser goes somewhere on the application, it sends it over to the server, and the server says, okay, yes or no, you have access to that or not. This behavior is quite similar to sessions, except that sessions are being passed automatically with each request, while GWT needs to be passed basically with code. But apart from that, they solve pretty much the same problems, or at least people use them to solve the same problems. Of course, some might argue that GWTs are bad for authentication, but I don't necessarily subscribe to that point of view. If people are using GWT for authentication, we should at least show them how to do it correctly. So let's go ahead and install the needed packages. We need to install quite some packages. If you have any problems with following the steps, of course, all the code will be uploaded on GitHub in the description below this video. But without further ado, let's proceed and install all the needed packages. So what we need to have NestJs Passport module. We need to have Passport, and Passport local we don't need. Passport local is a library to handle local authentication. So we don't need Passport local, nor do we need the types. We only need Passport and NestJs Passport. This is basically the Passport library, and this is the porting to NestJs, kind of a module for NestJs for Passport. So we need to install those two. Let's kill it and yarn add those. We also need to install GWT specific libraries. So here, NestJs GWT module and Passport GWT package of Passport. So it's a lot of libraries to install, but don't worry, you just follow the steps and everything is going to be okay. And we also need to install the types for those Passport GWT thing, because there's no library and they don't have TypeScript inside the repository. It's in another repository, and we are going to save it as a development dependency. Here we go, yarn add d for development dependency in types Passport GWT. Now we will have all those added here somewhere, right? And let's see how we can use them in our application. First of all, everything regarding authentication, of course, goes into authentication module. And that's a nice thing because everything will be organized and clean in our project. The first thing that we need to import is the GWT module. So remember what we have installed. This NestJs GWT is basically used to sign and decode tokens. This under the hood uses JSON Web Tokens library, so it's just a kind of a NestJs modularization of that library. while the other one in the beginning that uses passport, this is a true kind of module that ports passport to the NestJs. So the reason why I'm saying that is that this, we are going to use it in our service, while the other library, we are going to kind of put it in another folder called strategy, because the first time you see that kind of pattern, it's a bit weird. So we're going to import it here, GWT module. So this is to sign and decode the JSON web token, and we just need to register it. And there are several ways to do it. You can provide the secret, because the GWT needs to sign with a secret. You can provide it here, an expiration date and stuff like that. I usually like to leave it blank, because in most of the use cases here we're not going to use a refresh token, but most of the time when you deal with GWT, you also need to use a refresh token, and the refresh token will have a different secret and expiration date from the access token, and more about those in a minute. But that's why I kind of like to declare the module here and customize it further into the Auth service provider, right? So this is to sign and decode JSON web tokens. So let's do it now. Let's do it first. We go here, and since it's a module, because everything in NestJs are kind of modules, it also has a service, of course. Well, we need to import it again with dependency injection. And this GWT module is registered inside this module, so it will be accessible here. We don't need to make it accessible there, and the use case of that module is just to sign some tokens. So let's go ahead and do it. We need to import it here as a dependency injection, so private GWT service, right? And this is imported from GWT, from the same package. And if you have any doubt, you can also just check the package and see what's there. There's a GWT service, GWT module, and some interfaces. And I think it's actually a good practice to always kind of inspect a bit the libraries that you use. It will allow you to get a better understanding of what is inside, instead of just blindly following documentations and see things just appearing there out of nowhere. So we have sign up and sign in. Well, we said that we don't need to return a user. We actually need to return tokens. But to return that, we need to sign that information, like this user information, and transform it into the token, obviously like here. So we need to generate something like that, right? Based on, for instance, data like email and ID. So let's go ahead and create a function for that. This is going to be sign token. And I like to put it in a sync as well. And this sign token will take the fields that we need to sign. It's going to be user ID, which is going to be a number, and a email, which is going to be a string. So we're going to sign the user ID and an email. So later on, when he passes back something like that, we can get those two information out of that token and run validations, or assume that, oh, this is the user at ID 1. So whatever action that he does on our platform, check first if that he has authorization to pass that specific action, and then perform that action. So this is the kind of information that we're going to extract from the GWT and kind of trust what's inside. So we're going to construct an object that we're going to sign. Let's call it data user. Let's call it sub is user ID. Sub is just a standard of the GWT kind of convention that you need to use a unique identifier for a subfield, and let's add any field that we want. For in our case, it's going to be an email. And what we're going to do is that we're going to return this GWT sign, and all those functions come from JSON web token library that you can find on npm if you need. Sign async. And the first thing is going to be a payload, and the second The second argument is going to be a options for the signature, and this is where we can set our secret information that we're going to sign the data with, so only us know that information. So if a user comes back with a token, a GWT token, we know that it comes from us because we have signed it with our secret password. And actually we can name it payload because it's going to be more descriptive. Payload, and the second option will be an object. First of all, we want to set when that token will be expiring, so let's set it at 15 minutes, 15M. So that means that once we give that token to the user can do some actions on our platform for 15 minutes. After that, the token will be rejected and the user needs to sign in again. And we also want to add the secret, of course. Secret is mandatory, otherwise we cannot really sign. And for the secret, since it's a secret, we should definitely not commit it to GitHub. Let's put it into the env file as well. Let's call gwt secret. And let's name it whatever, like super secret. And let's copy that and use the same process that we have used into Prisma. Prisma service. Let's import the config module, private config service, and let's get that GWT here. Const secret is equal this config get GWT secret. Here we go. And since we're using TypeScript, we can actually provide some interesting function descriptions, like the return type is going to return a string, right? And here, and for sign in, for instance, instead of returning the user, what we do is that we return this sign token, user.id and user.email. Perfect. Since we return an asynchronous function, we don't need to put async here. This is only useful if we do some asynchronous operations with await here. Since we're returning the promise, we don't need to put it here. The code will know that it's a promise, and same thing happens here. And we don't even need to delete the user here. We can clean that out. And let's also return the user here. Awesome. Let's get back to our insomnia and pass the request. So now if we do sign in, it's going to return us. Of course, we forgot to start the server. Silly me. The server is running, no errors. Let's do the request again. And now we have a text, which is not very nice though. I didn't really want a text, but it gets us the JSON web token. And by the way, if we copy that and paste it here into gwt.io website, we see that we have the sub, which is the user ID, and our email. So this information that we have signed is correctly included into the body. Now onto the next part. One thing that we might to add is that instead of returning a string, because here is going to return a string, and of course NestJs is going to convert the headers to text.html, I'd like to return a object. So instead of doing that, we can just change the logic a bit. Here in our sign token, we can return an object with access token. I have noticed that usually the convention for access token is to have this snake case convention, and we can just return the access token here like that. And of course it's going to complain because our type now is incorrect. Our type is promise string, so it should be promise of object access token, which is a string. Now everything is working correctly, and if we execute the sign in again, we get a object with the access token key. Amazing. Now onto the next part, the strategy part. We have generated a access token, basically a token a user can use to pass requests, protected requests, to our application, the next step is to actually write the logic that will be able to intercept that token. So that token that the user passes to us, validate it, make sure that it didn't expire, and make sure that the signature with which we created the token is correct, and then only allow the actions that the user wants to do on our platform. So to summarize, we have written the logic that allows us to create a token, right? It returns a access token to the user. Then what would happen? Well, the user will call another route, for instance, users/me, to get the information about the current user. And he would provide in the headers an authorization token, something like that, bearer, space, and that would be the access token. So the logic that will verify that this bearer token is correct is called a strategy, and this is what we're going to implement now. For that, we create a folder in Auth module called strategy. We'll create a baron export, and we'll create a strategy, which is basically just a class, strategy.ts, the strategy.ts, export class gwt strategy. We have an example in the NestJs documentations. Let's check it out. Here, the strategy should extend the passport strategy, which comes from the NestJs passport module, and it implements the gwt strategy, which comes from this passport gwt library. And what it does is that it configures it in the constructor calling super. So it calls this module, this service. It says that the gwt should be extracted from the headers as a bearer token. So it just means that it should have this kind of format, bearer space token, which is a standard for a bearer token. This property is set to false by default, so we don't need to set it to false. It just allows us to ignore the expiration date of the access token, which can be useful when we are testing, but we don't need it at that point. And it takes the secret key as a parameter, and the secret is basically this thing that we have defined here. We have signed our token with a specific secret. Well, we need to allow the strategy to decode that same token with that kind of secret. Not really to decode, but more to verify that the signature of the token has been really signed by that secret. So we know that the token comes from this server, from our API. So let's go ahead and implement it. The gwt strategy should extend passport strategy that comes from NestJs module passport, and it should take the strategy that comes from passport gwt, right? And it has a constructor because we are extending a class. We need to call its constructor, the constructor of the parent class, like that. And we need to provide the configuration of that passport strategy class. So we can just go ahead and copy what is there and delete that because it's false by default, and import extract gwt, and this is basically the secret, right? So this class is also a provider like the Auth service class, right? So it can use injectable. The reason why we separate it in a different folder is just to make sure that we know that this class has a specific use case, and it's for validating the token, the access token. So that's why it's inside a folder. But it can also use dependency injection under the hood. So that means that it can inject Prisma, inject gwt, and inject the config. And this is what we need, because we need to get that secret from the environment variable. So let's go ahead and do it. Injectable. And here is going to be config service, config.get, and it's going to be, I think we called it gwt secret. Every time I forget how we call things. gwt secret. Amazing. Now Now everything's okay. The only thing that we need to do is that we need to export that class from our baron export, which is a good pattern. And we then need to import that strategy as a provider. So NestJs is aware of that strategy being part of our application. So gwt strategy. And that's all we need. Let's go ahead and start the server. Nice, everything seems to be correctly instantiated. And we now have the gwt strategy configured. Now we can protect some of our routes with that strategy. That means that you can access a route only if you have a valid strategy. Here we are using gwt, but if you want, you can also have strategies like login with Facebook, login with Google, and they have their own configuration options and stuff like that. So again, we generate the token with the Auth service, and then we have a strategy that we can decorate other routes with, so only people with the valid token can access it. But we don't have any other routes, any other controllers apart of the Auth controller. So let's go ahead and create one in the user module. I'm going to use the CLI NestJ controller user. I would name my controller users based on the REST API format. And let's go ahead and implement a simple get endpoint. It's going to be get me. If you leave get decorator blank, it will catch any requests. So it will catch any requests like that. If you put something there, it will actually catch it with that pattern. So if you leave it blank, it will just use the pattern of the controller to catch it. Obviously, if the controller has nothing, it will try to catch it at root, which is not a very good idea because it can have conflicts and undesired behavior. But in this case, we are going to use me. So we are going to call that endpoint with users/me. And in me, we are going to return something. Return user info. It's just a string, right? Right now, we are not doing anything. And if we go back to Insomnia and call users me, and let's actually delete that. And it's not a post request, it's a get request. It's going to return us user info because we have just mapped that route onto our application, but we haven't protected it, right? So there's a, so to protect an endpoint, to kind of have a condition that will say, okay, if you meet certain conditions, we are going to execute that logic. Else, we are not going to execute that. To do that in NestJs, we use what we call guards. And again, you can use the NestJs documentation to read about guards. A guard is basically a function that will stand in front of a route handler, so in front of an endpoint, and it will allow or not allow the execution of that endpoint. In our case, our guard will check for the strategy, and if the strategy, the gwt strategy, is correct, it's going to allow the execution of the route. If not, it's going to block it. You can, of course, create custom guards, but in our case, we can use something that has already been pre-made, and that comes from the NestJs passport module, and it's a node guard. So to use guards on a given route or on a given controller, you can use pretty much everything at a global level, at a controller level, or you can use it at the route level. So in our case, we want to block the get me route if you don't have a valid token. So let's go ahead and create that. We need to use a decorator called use guards. And in the use guards, we can provide the guard that we want to use. And NestJs passport, the module that we have here somewhere, actually here, NestJs passport, it already has a guard to work with that strategy, right? So if we inspect the code here, we see that what does it have? It has a node guard, it has some interfaces, it has passport module, but this is what we are interested in. It's a node guard, and it's basically a guard that is compatible with NestJs that we can use, and that works very well with the strategy. So let's come back. Let's go back to the user controller and import it here into the use guard decorator. So Auth guard, and here in the parentheses we provide what kind of guard it is, what kind of strategy it is guarding for. So it's GWT, and when we create our strategy with that strategy object that comes from passport GWT, it by default assigns the GWT kind of key to it. So you can assign any key that you want, for instance GWT2, but by default it just leaves it like that. So it will be identified by the Auth guard with that keyword. So if you have a refresh token, you can do something like that. You can name it really the way you want. You can give it any name that you want. But by default it's GWT. You can leave it blank, or you can leave it here GWT. I will prefer to leave it like that because it's going to be clearer. It's going to be a bit less of magic, because the first time I encountered the Auth guard, I was wondering, how does it know that this GWT is linked to that strategy? And that's how. So we are going to say that, oh, this route should be protected by that strategy. Now let's go into Insomnia and try to use the same request again, and see we have a 401 status, unauthorized. Well, it's because the strategy is being executed and it does not receive the bearer token, so it throws an error. So let's recreate a bit of flow. I clean up the database. I have now 3 routes: get me route, a sign up, and a sign in route. So let's go ahead and sign up and create a body, email vlad@gmail.com, password 123, and let's create the account. We have an access token. That access token, we can use it in our bearer token. So if we throw the request in right now, if we use the request right now, we're going to get a 401 because we haven't given any bearer token. Let's go ahead and implement it. Authorization bearer, and then we paste the token. And now we have another error, which is interesting. Let's see what is going on. This validate is not a function. Okay, we forgot one function in the GWT strategy, and it's validate. So let's go ahead and write it. And it's going to take a payload of any, and let's log that payload. Cool. One important thing that we forgot to implement is that we forgot to have a validate function. So the token is going to be transformed into that object and put into payload, and then we need to return it. So here we can perform any validation that we want, and then we can return the user. In our case, we are just returning the JSON. So what it's going to do by returning the payload is going to append the payload to the user object of the request object. It sounds a bit confusing, but under the hood of NestJs, we use express, right? And we can get the request and the response of express with the right decorators. I have shown it in the beginning of the course, right? What the GWT strategy does is going to append a user object to the request object, so we can use it in our route. So the user is going to be that payload. So it's going to be that object with the sub, email, expiration date, etc. So let's get back to the strategy and just run it again. It is passing correctly, right? So we have the console log of the payload here. As I said, it's an object with a sub of the user ID, email, our email, and other information that was contained in the token, right? So let's clean that and let's see why is it useful for us? Well, if we go back to the controller, I said that the strategy will put that decoded payload, or whatever value we pass here, whatever value we pass in the validate function, is going to append it to the user object on the request object of the request of the API. So we can get that object here, request, actually rec, and the rec object is from NestJs, and request interface is from Express. And we can do console log user is equal to rec.user, rec.user, and you see that even Express knows that a user is possible because when you validate the identity of a user, its identity can be appended to the request object. So here we are going to log that. It's going to log the payload, so the object that we have returned from here. So if we run the request again, we come back to the thing, and we see that we now log the same payload, but from the controller, because we have written user here. So if we pass any other value here, let's say hi, well, hi is going to be logged here because we basically attach whatever we export from the validate function to the request user object, right? Does it make sense? If that doesn't make sense, don't worry about that. We are going to build upon that concept, and I'm going to come back to it a couple of times. So basically that means that we can get the information of the GWT from the token and do something with it. Since we have an ID, we can get the user by that ID. Since we have an email, we can maybe get the user by that email. Everything is possible. We just know who that user is that requests the user's me endpoint. Let's clean the strategy and return the payload. We can close the strategy file and come back to the user controller file. So what we're going to do now is that we need to get the information of the current user based on the access token, right? So now we need to get the information of the user and return it back. So that can be done in several ways. In that example, we're going to get the user object from the database directly in the validate function. So on top of having config, we also need to inject Prisma service, and here we can get the object. So it's not going to be any, it's going to have a sub field which will be a number, and it's going to have an email field which will be a string. Validate will be an async function. We can get the user, const user is equal await the Prisma, and I forgot to put private. The reason why I don't put private in front of the config is because if we do something like that, I can't really use this because super must be called before anything. And since I'm not using config in the rest of my application, there's no point to use private. And remember, when we use private, it just means that we declare the variable here automatically, right? So we don't need to do that. I can leave it without private, and of course it's going to be config.get, but here we can use private because we use it elsewhere. So this Prisma user find a unique, it's going to be where id is equal payload.sub. Also, very important thing to notice is if we return null, it's going to throw an error, right? So if the user will be null, if the user will be not found, a 401 error will be returned, and if the user will be found, that user object is going to be appended to the user request object on the request. And the thing that we can do before doing so is to delete the hash, so we don't inadvertently export some sensitive information, and then we return the user. And in our user controller, what we can do is that we can return rec.user. Now if we run the request user/me, we're going to get back the user based on the access token. And now we have our application working. We can sign in, sign up, and get the information of the user. So that's quite cool. But there are a couple of things that we can enhance. Before I told you that you should not use the request object immediately because it is error prone, and this is correct. So we can fix that. And we also can make that a bit more clean. So this is easier to do. So let's start with that. Every time that you need to put a string somewhere, it's called a magic string, it can create errors. And we can make that cleaner by abstracting it in its own class. So let's go ahead and do that. This functionality will be part of the Auth. So let's go ahead and create a guard, a custom guard. So new folder, guard. And again, the backend export here, and we are going to create the gwt guard.ts. And what it's going to do is going to just be a class gwt guard, and all we need to do is to extend the Auth guard, and we are extending a guard with gwt strategy. And that's pretty much it. We might just run the super. And we need to export that class so we can use it in our application. So instead of writing Auth guard like that with those strings, we can just write that class. And let's export it and import it in our user controller. gwt guard. And if we run, and if we check the runtime, it is executing correctly, and we can even get the information correctly. Oh, 401 unauthorized. And we can so this is similar to what will happen in our application. We get a access token for a specific amount of time, and once it is expired, you cannot use the protected route anymore. So we need to get a new one. So let's go ahead and create a request email vlad@gmail.com and password 123. We get the new access token, and then we come back to the header here and replace it with a new one. And if we send a request, it works correctly. So now we have fixed that, and let's go ahead and fix this. This is a decorator. So you know all those things are decorators. We have made a custom guard that extends the Auth guard provided by NestJs Passport, but we can also make a custom decorator that will go in the request object and get that user object and return it back to us. So now you can go in the Auth folder because it's kind of part of the Auth functionality, right? We can create another folder called decorator, and again export the backend with the backend export, and let's create a custom what we call a param decorator. And I don't remember the syntax by heart, and obviously that's why as programmers we have documentation, so use it when you can. You're not supposed to know everything by heart. And in the custom decorators documentation we have param decorators, and that basically means that you can put them in the parameters of your endpoints, and there are a lot of them already defined. You see that you have the request that we have already seen, there's session as well, you have IP, headers, query, body that we have used, right? And they say that you can create a custom decorator, for instance, to get the user object on the request object. And the way to do it is like that. So let's just copy it, and I'll explain in a minute what it does. So let's go and create our decorator. Let's call it get user decorator.ts, and let's call it get user and that's it. It is creating the param decorator that we can use like that. Get user, right? And it, in fact, it already knows it. And what it does is it can take a data that you pass to it. For instance, that would be data, but by default it's unknown, so you don't need to pass it. And the second argument, it actually gets the execution context of the request. So it's important to understand that NestJs is an abstraction, right? It uses something under the hood. It can use Express, it can use any other protocols. Here we say that this execution context switched to HTTP because we're using HTTP, but sometimes you might use, for instance, WebSockets, right? Or you can use RPC for something like microservices. In our case, we use HTTP, and then we say get request. There are other things that you can do. You can get the response as well, but here we want to get the request, so it's going to get the request object of the Express library, right? And then we can do something with it. So this request will actually be the same as Express request, if that makes sense, right? This request is going to be that, and then it's going to return whatever we want from it. So the decorator will put in a variable here whatever we return to it, and it's going to be a user. And in our case, since we have used this strategy, in our case the user object will be the user object from Prisma, right? That's all we need to do for the custom decorator. Let's export it from the Baron export file, and in the user we want to use the Baron export pattern. So it's going to export it from the decorator file, and here we don't need to put any data. For now we're going to leave it blank, and here user is going to be of type user, and that will come from the Prisma client. So in the beginning of the video I said that Prisma generates TypeScript typings for us, so which is very cool. So now we can say that this variable is of type user that was defined in our Prisma schema, and now we can just return the user, and it makes it all clean. And that decorator, you can reuse it pretty much everywhere. Now we can also optimize that logic a bit by moving the guard on the controller's level. So that just means that everything that is in the user controller, well, it will require you to have a token. It will require you to provide an identity of who you are, which makes sense. That way, if we have another endpoint here, for instance, patch, edit user, well, we won't need to copy the guard here as well. We can just put it on the global level. So let's go ahead and run our request again, and everything is working. So let's say that in this case, you don't really want to pass the whole user object. You just want to pass the ID. So you can say, I just want the ID, and then it's going to be user ID, and it's going to be a number. So you can say something like that, and then in your logic, you can get the ID of the user. If you want to do something like that, it's quite easy. You come back to the get user decorator, and you say, well, if there's something in the data, then you return request user data, and data will be a string, and it could be optional. So if we don't provide it, it's going to return the whole user object. If we provide it, it's going to return a field from the user object. So we can actually try that out here. And here we say we want to get the email of the user, and it's going to be a string. And we can, before returning the user, console log that email. Let's run the request, and if we come back here, oh, there's something that's not working. A required parameter cannot follow an optional parameter. Let me go back to the get user, and here, okay, I see. So instead of doing like that, and this is true, a optional parameter can only be put at the end. Here the order kind of matters, so we will say string or undefined. So that way the data could be potentially undefined. Let's go back and throw the request, and we have a log of our email, and at the same time we get our user. So everything is working correctly. Let's clean that up, and we don't need to get the email anymore. So thanks to those tools, decorators and guards, we have created quite a clean logic for our application. You see, everything is quite organized and everything has its place. There are a lot of decorators that NestJs has, and it allows basically you to save some code and have something, well, I would say ergonomic from a visual point of view. For instance, there's another decorator that I use quite a lot and that I haven't showed yet. It's HTTP code. So usually when you create a resource on the server, you send back a 201 HTTP code. So if we go ahead here and create a new user, Vlad2, the status code will be 201, right? So that just means that the server has created something in a database. That's kind of a standard. You can, of course, make it return 200. So for that, it's going to be HTTP code. That's the decorator, and inside the decorator, we're going to return a status. So for instance, it could be 200. NestJs also has enums, so instead of returning numbers, which is error prone, you can return enums, HTTP code, HTTP status, and you have accepted, found, and it basically means different codes. So code 200 means okay. So, and if we put the mouse here, we see that 200 is equal okay, and there's a lot of other codes that are used in the development. So you see here's a whole list here. Not found, for instance, that is very known. 404, 401 unauthorized, that is thrown by the strategy when the bearer token is not correct, and forbidden, for instance, 403 when we throw a forbidden exception. So we can do that. Obviously, when we create a user now, it's going to be 200, but by default a post request will return 201, so we don't really need to change that. However, when we sign in, we don't really create any resource, so I'd like to return the code 200, so we can use it 200 here. So instead of like signing in with a 201, it can be used to sign in and get a 200. So that's quite cool. So post requests return usually 201. Get request will return 200, so we don't need to specify a HTTP code decorator here. We have implemented quite some features already, and you see that our application starts to grow. We'll soon implement the user routes, for instance, the patch user route. We will also have bookmark routes, and our application will start to grow, and it's going to be very tedious to actually go in Insomnia and run all those kind of tests manually. Imagine you have something like 100 endpoints and you need to test several use cases. For instance, like, oh, I'm signed up with a profile of admin and the admin should be onboarded, and then he should do that, and then I need to sign up with you. Oh my God, it's pretty much impossible to test manually. So that's why we use automated testing. There are three kind of main levels of testing. You have unit testing that you probably have heard about. Unit testing will usually take any functions. For instance, it's going to take the signup function, is going to mock any dependency that the signup function is using. For instance, argon or connection to the database, and it's going to try to make sure that this function is executing and calls the right things, and everything is working correctly on that unit level. However, that takes a lot of time, and to make it right, you need to actually practice a lot. There's a lot of methodologies how to do unit testing, and it can be really nice when you have a project where a lot of people work on and a project that will spawn through years and years of development, unit tests are a good investment in terms of your time. However, in most of the cases, what we want to have really is end-to-end testing and integration testing. So we have unit testing, just above we have integration testing. Integration testing will kind of take several modules, and that's why NestJs is so cool, because by default it separates our application into modules. So for instance, I want to check the Auth functionality only. Well, I can load the Auth module and the Prisma module and maybe the config module, and I can test only all those three together. And when I'm happy with the result, I can just test something else. User. A user, well, for the user we'll need to have a user, so it needs to use the Auth module, so we're going to use the Auth module, user module, Prisma module, but not the bookmark module. And we kind of can test all those together. Integration testing, you define some segments of your app and you test them together. I like to test it with a test database. So on top of having a devdb that I use for like manual testing and manual feedback, I'll also have a testdb here in our Docker Compose that I'm going to spawn and destroy every time I do my tests. So you have integration testing, and then you have end-to-end testing. And end-to-end testing kind of verifies a very high-level user journey of your app. So, okay, user signs up, signs in, he requests his profile, he does that. So it mainly verifies how the user will interact with your app. While integration testing, we can really test a lot of things. For instance, well, is the sign token working correctly? If the sign token with sign in is working correctly? Are the exception throw correctly? So this is more for integration testing. Since testing takes a lot of time, usually it's estimated that testing takes at least the same amount of time that you have spent on creating your app. So if you have spent something like 2 weeks building your app, you'll probably spend at least 2 weeks testing it. There are various methodologies for testing. There's test-driven development where you write your app as you test. Obviously, we have not done that here, and it can solve some problems as well. But in our example here, in our small CRUD application, what we can do is that we can use end-to-end testing. So end-to-end testing will allow us to kind of showcase the use of our app and prove that it kind of works. We don't need to go into details and make sure that everything works together. If you're interested by that, you'll probably be using integration testing. I have a video about that on my channel. So if you are interested about that specifically and how to do it with Prisma, well, be my guest. There's a 1-hour video on the subject. But in our example, we are going to use end-to-end testing, and I'm going to use a library that has been suggested to me by one of the core developer of NestJs. And I have to say it's quite cool. It allows you to save a lot of time, and it's called Pactum. By default, NestJs uses supertest for the end-to-end test, but in that example, we are going to use pactumJs. So without further ado, let's get started and create our end-to-end test so we don't have to jump between our code and Insomnia over and over again. Okay, so let's start with that amazing endeavor. And first of all, let's install Pactum. Yarn add Pactum. So Pactum is an amazing library for testing your APIs. It is really nice to work with, and it works very well with GraphQL, and it has a lot of features that we're going to use straight away. And to install it, all we need to do is to install it with Pactum. So before we start our test, we'll need to consider a couple of things. First of all, we will have to set up a test database for our end-to-end tests, because we want to keep the devdb actually separate from the testdb, so we don't delete our database every time. So that's one thing. And the second thing is that we'll have to set up the database, set up the Prisma service to be cleaned up every time we run our tests. But before doing that, let's clean up our app end-to-end spec file. We can just go here and delete everything. So how NestJs works is that it's going to compile a module, and we're going to take the whole global module, the app module, is going to compile that, and we can create a test module out of it. And on that test module, we can call requests like we do with Insomnia. So let's go ahead and first create a describe block. So it's going to be app end-to-end. And inside that app end-to-end, we will just run a test, a to-do test, should pass, just to see that if our script is running. And we are going to kill our server because we don't need the server anymore. We are going to kind of use what we call test-driven development. We are going to write tests and write logic and make sure that our tests are passing. So the way to run that file is through test end-to-end. Here there's a script already created for us by NestJs. So yarn test end-to-end, and let's see if that at least works. And we see that we have a pass test, nothing really happened, but that's fine because we haven't defined our test yet. So let's go back to our test and create the Prisma module. So before all the tests, what we're going to do, and it's going to be an async function. It's kind of a hook that is provided by Jest. We're using Jest as our main testing framework. Those describes come from Jest, and we're going to use pactum for the requests, to send a request to our server and to analyze the answers to responses from the requests. So before doing that, we need to create a module, const module ref await test. The test is going to come from nest testing, NestJs testing. There will be a test create testing module, and here we import, and that's basically a module as we have here in the app module. So we create a module that will import that app module inside it. That's the easiest way to do it. App module. So the app module comes from here, and we are going to say compile, and that's pretty much it. For end-to-end test, we just import everything because everything needs to work together. And what we need to do then is to, well, let's see if that passes to begin with. All right, amazing. Now what we can do is to avoid every time that we want to run the test, to avoid that we have to go here and do yarn test end-to-end, we can set the test to be kind of automated. So they run automatically as soon as they detect a change in our code. So we go back to packer.json and say just watch. One important thing that we need to say as well is to disallow the cache of the test in case we don't run into problems where some resources might be cached. So that's fixed as well. Let's go ahead and run it and see if that works. So now it should be running continuously, and if we save, nothing would happen. But if we run a new test, it should automatically recompile it. So it will detect if we have any new tests in our application, and if I press A, it's going to run all the tests again. That's pretty much just usual just I would say flow. You press W to get more options, but for now that's all we need to do. And let's delete that test and see if we can connect to our test database right now. And let's add a couple of things. Basically what we are doing here is that we're simulating the server. So anything that we have defined in the main TS, we also need to define here in our testing module. Here we use global pipes. If we don't include those, the DTO validation in our test will not work. So we need to also include those just before here. So now that we have the module compiled, we need to create a NestJs application, testing application. So we can say app is equal module.ref, create module ref, create nest application, right? So it's going to try to emulate an app. Here it just compiles a module that can be useful when you run integration testing, but since we really want to run an end-to-end testing, we need that. Also app, we can abstract it in the describe here, nest application, and app will be this. And now we can include the pipes, otherwise the validation pipe will not work. It needs to be as close as possible to our real server. And at the end, we say await app init. So this is where we kind of start the server. And when we're done, when all the tests are done, what we do is that we do app close. So we close the app, and we see that now it is still working. Everything is good. This is our starting logic. This is our tear down logic. We can close that. And now let's think about the database. Well, by default, NestJs, in our case, will connect to our dev database. We need to have a dedicated test database for our test and a dedicated dev database for everything else. So how are we going to do it? First of all, let's create the devdb in our Docker Compose. So just copy here and testdb. Testdb is going to run on port 5 and 5435, so it should not be running on the same ports, otherwise you will have a problem, and the rest can pretty much stay the same. We can now go back to the package.json, and we see that we have those scripts for the devdb, right? Well, we need to have the same scripts for testdb. So let's copy that and write it here, testdb restart. So, and just copy all the scripts here, and those will be for test. Prisma test deploy, db test remove, and db test up. So for the test db, it's going to be just testdb, Prisma deploy, and here in the db restart it's going to be test remove yarn db test up and yarn Prisma test deploy. Okay. One important thing though is that Prisma does not manage the environment variables by default. So here it's going to just load the environment, the database URL from the environment file that it detects. So I need to be a bit more specific here. This means that Prisma will try to find that variable from the environment variables, and if it doesn't find it, it will try to get it from the env file. So one thing to work with Prisma with different environment variables, because you can just create another .env.development, .env.testing, that would not work well with that. The cleanest way I found to manage environment variables with Prisma is to use a npm package called dotenv CLI. So let's go ahead and implement it. Yarn add dotenv CLI. So what it's going to allow us to do is to inject the .env file of our choice in our kind of scripts. So by default, if we just stay on the environment variables, it's going to get this environment variable. So if we don't do anything, everything is going to be loaded immediately from this one, right? However, if we If we want to use another environment variable such as env.test, it's a bit more tricky to force all our code to use this one, because Prisma will automatically only get the .env. It doesn't know about .env.test, and it cannot know about it. The config module from the API tutorial can load that specific one. For instance, it has a variable called env_file path, and you can specify where the environment variable is, but we'll have to create a lot of filler code, and it's going to be quite ugly. So it's better to use .env CLI. It keeps our code clean, and we don't need to change anything here. We just need to include that library here. So let's go ahead and do that. So if we are using the .env development, we don't need to use .env CLI, because by default it's going to be using this one, and this one will override any other environment variables file. However, if we use the test ones, we need to inject this one first. So it's very easy, to be honest. You just do .env.e, and you just provide the path to the environment file and .test, and then you just execute the rest. This is specific to Docker, so Docker doesn't need to be aware of the environment variables. However, when we run our test, we also need to make sure that the NestJs is loading the right environment variable, not this one, but this one. And for that, we also need to include here. So we include .env-e.env.test on the test end-to-end and on the deployment of our migrations, right? And let's come back to .env.test and let's just clean that here and implement that new string. But instead of the port 5434, we're going to have the port 5435, which is the right port. Now to test it all, and this is the moment of truth, let's go ahead and kill it and do yarn test end-to-end. Also, an important thing is that we need to create a hook for test end-to-end. So when we run the end-to-end test, it needs to run the db test restart. So it's going to clean the database, the test database, and it's going to push the migrations on that test database, and it's indicated in the .env.test. And to define a hook in package.json scripts, so we just say pre, and we put the name of the script here. So if we execute that, this is the hook that's going to be executed before. And we do yarn db test restart. And just to make sure that everything is correct, db test restart. Okay, let's try that out and see if that works. So we see that the hook is working and everything seems to be correctly working. Now, to make sure that the migrations have been pushed into our testdb, so let me just open a new terminal session and I just do docker ps, and we have now two databases, one that has been created just now, and it is the database on port 5435. It is our test database, and this is the old dev database on port 5434. So what we want to do is to make sure that this database has a migration. All we need to do is to use Prisma Studio, but remember that Prisma is also using this .env file. So what we can just do is to force Prisma Studio to use this one with the same technique that we have used here. So .env-e-env-test, let's copy that. And it's npx because we are running it from the terminal. And we do Prisma Studio. And that should automatically connect us to the right database. Now we see that the studio is blank. However, if we connect to the other one with .env, we will be connecting to the dev database, and here we have some fields that we have been testing with Insomnia. So everything is working correctly. We can clean Prisma Studio. We won't need it for our tests. And let's come back to our testing logic. If you have any questions regarding that process, feel free to drop them in the comment section below. I will try to answer as soon as possible. But all the code here will be available in the GitHub repository in the description of this video. So if you are stuck somewhere, just check there. And I'm going to clean here because everything works correctly. And yeah, let's start our testing process. So now we're connected to the testdb via this environment file. Everything is okay. Let's go back in our testing module. So what do we need to do first? Well, first of all, before running our tests, we need to make sure that the database has been cleaned. And of course, every time we run our end-to-end tests, the whole database is actually restarted, so cleaned and restarted. But when we run our tests in the same kind of jest session, we also need to clean the database. We don't need to restart the Docker container because that takes time. That takes like 3, 4, 5 seconds, and we don't want to wait all that time, right? So what we want to do is that we want to tell Prisma to clean everything that is in our database every time we run the tests, right? So because we have a just end-to-end session that is watching, so that is keep going, it doesn't stop. We need to do it manually. So it's quite easy, to be honest, to do it. But let's first examine our schema to make sure that we are doing the things right. So what should happen here? Well, every time we run our test, we need to delete the users and the bookmarks. And sometimes there could be a problem where, for instance, the bookmark is linked to a user, right? But what happens if you delete the user first? Well, if you delete the user first, the bookmark suddenly might be without a user, and that could be problematic because that can create errors. To make sure that we don't have any errors and that elements are deleted in the right order, we can either tell Prisma to delete first the bookmarks and then the users, but that can be a bit daunting because imagine you have something like 20 models, so your teardown logic of your database can be quite long. Or you can do something like that. You can say on delete, and we just say cascade. That means when the element that is, it is the kind of the parent of that, when the parent model of that bookmark is deleted, the bookmark should be deleted as well. To implement that, we need to run migrations. I'm not going to do that. I'm going to go with the other option, where I'm going to make sure that the bookmark is deleted before the user. But know that it is possible, and in some case it is really good to have a on delete cascades, unless you really want to conserve the data in your database. So for instance, you can in an app have categories and posts. Let's say that the user decides to delete a category. Well, you can say what happens with the posts in that category. Are they kind of set to, are they just, do we keep them or do we delete them as well? In our case, if a user has been deleted, the bookmarks should kind of be deleted as well. I don't see why would we keep the bookmarks, so on delete is set on cascade. But in some application, you might want to keep the user data, you know, you never know. But know that it is possible to have those kind of hooks on Prisma, but I'm not going to go with it because I don't want to run the migrations. I'm going to just show the other way. The other way is to go into Prisma service, and we need to implement a new function. Let's call it cleanDB. And what does cleanDB? Well, we need to tell it what it does. And we need to delete the bookmarks and the users. So we can do return this Prisma. Sorry, actually user. It works like that because this is actually Prisma. So this is the Prisma client. User delete many. So what do we need to have here? We need to delete all the users and we need to delete all the bookmarks. And of course, since we need to do it in order, it needs to be first bookmark and user, right? Except that Prisma kind of optimizes our request and could delete the user before the bookmark. So to avoid that, we can use transaction. A transaction is when we tell Prisma to make sure that the things are done in the specific order. So this transaction, and we just provide an array, and elements will be executed one by one. So we first need to delete the bookmarks, and then we delete the user. So we don't have a case where a bookmark can be without a user. And we just need to return that, and that's it. That's all we need to do. This is our teardown logic that we need to run before our end-to-end test. And let's come back to the end-to-end test. In before all hook, we need to make sure that in that logic, the database is reset. So how do we get the database? Well, it's actually quite simple in NestJs because it uses dependency injection. So you can do app Prisma. Let's just declare our Prisma service here. And now we can say Prisma is equal to app get, and we can get any provider that we want. It's called Prisma service. And it's going to just get that Prisma service, and we can put that into the variable, and we can call that variable like that. Await Prisma clean DB. So it's quite cool to do tests with NestJs because it's just a nice experience. And we can come back here and we see that property clean DB does not exist on type Prisma service. That can happen sometimes when you write code and you didn't allow NestJs to recompile the files. So in our case, I think we need to just restart the server, and that should work. So if you are doing major changes to the underlying logic, to the services, you might actually need to restart the end-to-end test because it needs to compile the files into JavaScript, right? And that's it. And let's go ahead and now create our end-to-end logic. We can close that, collapse this. We don't need to touch it anymore. And we don't need to touch it either because as soon as we close the app, the Prisma connection to the database is also closed. So we are quite happy. Now let's create our tests. So describe Auth. What do we need else? We will have user, and we will have bookmarks. So you notice that I actually write the tests first before we even have a, for instance, bookmark logic, is because that will allow us to kind of have a structure already and think about our application before we even build our code. So what should be in the Auth? Well, it should be sign up, and there should be sign in, and that's pretty much all there is. Then we should be able to get the user, get current user, or more like get me. Then we should be able to edit user. And for the bookmarks, we should be able to get bookmarks, create bookmark. We should be able to get bookmarks. We should be able to get bookmark by ID, maybe edit bookmark, and delete bookmark, because that way we'll have our CRUD application. Now NestJs complains because we haven't created a single test. Let's go ahead and just create a to-do. I think it will be happy with that. Should sign up. Let's see if that works. Okay, that works. So we have should sign up. We also have should sign in. And let's start by that. So this is kind of our testing structure. Now we're going to run our test, write our test actually. And for that, we are going to use pactum. So to run the tests with pactum, we first need to import it with import all as pactum from pactum. So after that we have imported Pactum, we can now use it in our application. But Pactum is a request making library. It needs an API, it needs the server to make requests to. And so far our servers, our NestJs app, it just has initiated the Nest application context. We also need to start a server by providing await app.listen, and we can provide the port at which we want the app to listen. And now we can do the request. So we can go into our first route, a to-do, and we can provide a callback function to that test. And what do we call? We call return pactum spec, and then we provide the request type is a post request to auth to HTTP localhost 3333 auth sign up. And then we need to provide a body as well with body, and the body will be the DTO, the auth DTO, and it will take an email which will be vlad@gmail.com and a password which will be 123. And we will provide that email here, and we shall expect a status of 201 because we're creating a resource. So let's get back and see. Okay, perfect. That test took 42 milliseconds and that has succeeded. If we want to see what's inside the request body, we can just call inspect at the end of the promise chain. And the body here has been logged along with the code and the headers. So you see that we have the headers that is powered by Express, the status code is 201, and we get our access token. Now this is a bit verbose because every time we're going to call the API, we need to write that. This is called also the base URL. So what we can do is that we can abstract that away from this post request. So we don't need to repeat it in a subsequent request. So we can do pactum request set base URL, and we can just provide that base URL. And instead of writing the local host here, we can just write auth sign up. That is much cleaner, much shorter, and that does the same effect. Let's get rid of the inspect to see if our test is passing, and everything is nice. So it just took a bit more time, but it's just independent of our logic. Okay, now it's amazing. The DTO, we are going to reuse it in our whole auth application, kind of auth flow. So we can just move it above. And let's also test if the sign-in route is working. So we are going to delete the to-do here, provide a callback to the test, and return auth sign-in. Since it's a end-to-end test, it will first execute this code. So we will have a user, and then it's going to execute that code. And obviously it should be 200. And let's see how it works. Amazing, everything works together. So we have tested that we can create a user and that we can sign in. Usually when you write a test, you also need to test the use cases where your test will fail, right? So for instance, before writing should sign up, we should actually write it should throw an exception if email empty. So we can also write all that to test if that logic will throw. So we can just copy that, put it here, and say that we expect a code of 400. So we're going to write 400 status code to be expected because we expect the error to be thrown by the validation pipe, which returns a 400 error, bad user input. And we also need to provide a DTO without the email. So what we're going to do is that we are just going to provide just the password 123, actually DTO.password. So we reuse that DTO, and let's see if our test is passing, and we see that the test is passing. Next, we can also check the other way around. So should throw if password empty. So instead of having the password here, it's going to be email and dto.email, and should also throw 400, right? And we can also test both, just in case. Should throw if no DTO, no body provided, and I'm just going to do it without the body. And we can do pretty much the same with the sign in. So we can copy that and test it with the sign in here, except that it's going to be sign in everywhere. Let's go ahead and check our tests, and everything is passing. And that's pretty much the process of kind of end-to-end testing. It doesn't really test how our modules, how our functions interact with. So we might return the right status, but maybe something in the database is not saved in the correct format, and that we are not going to be able to verify that with end-to-end testing. End-to-end testing is not designed for that. End-to-end testing is just there to make sure if the app is working end-to-end. So if kind of all the functionalities are working more or less as expected. If you need to go in more details, you're going to actually create integration testing, and that's out of the scope of this tutorial. Now, a very interesting part is that we need to check the user information, right? But for that, we need to send the bearer token. So Pactum provides a very neat functionality that allows us to store a variable in the Pactum execution context. So we don't need to create a variable somewhere. For instance, we don't need to do something like that. Access token, and then assign it somewhere else based on the of what our API returns. What we can do is that we can use the store API of Pactum. So here in should sign in, let's inspect the body response that's going to be returned. So we have the body and we have the access token. So we can actually save that value in the memory of Pactum. So let's go ahead and use that functionality, and it's basically a stores function, stores spec request and response data, and we can choose what we want to store. So for instance, it's going to be user AT, user access token. It's kind of like assigning a variable, and the path to that variable will be access token. So it's going to get the access token from the body, the access token variable from the body, which is in the JSON, and it's going to put that into that variable. And later on, we can reuse that variable in our requests. So let's do it here. Get me it should get current user, return Pactum. Let's just copy that here, and we are going to put users me, and it should not have a body. However, it should have a authentication headers. And if we check the code right now, let's rerun that. We see that get current user, we have a status of 404. That's interesting. Why is it? What is going on with it? So users has that controller and me. Users me. So why is it not working? That's very interesting. 404 cannot post. It's a post request, of course. It expects a get request. So get. And now it says that it's 401, unauthorized, because we don't have the access token, right? So let's go ahead and pass the access token in the same way we have passed them in Insomnia. Remember, here in headers we have we have authorization, bearer, space, and the access token. Let's go ahead and do that here. Headers, with headers, and we can provide a object key value. So the key is authorization, and the value is bearer. And to inject that variable that we have saved here, there's a special syntax in Pactum, and it is this thing, a bit like what we have in template strings with JavaScript, except that you have an S here for store, and you can put the name of the variable here. And normally we should get a correct answer, and we can even inspect that to make sure that we get the correct one. And you see that we got the user object that was expected. In a nutshell, that's all integration testing is. Most of the time you will just test if the status code is correct. And at that point we have tested all our routes, and what is left is to actually write the logic for edit user and write the logic for create bookmarks, get bookmarks by ID, edit bookmark actually by ID, and delete bookmark by ID. So this is what we are going to do in the next part, in the next section. We are almost there. We have almost finished our CRUD application. So what we need to do now is to create the logic for the patch request and the CRUD request in the bookmark module. Let's first start with the patch request, and we are going to need the service here. We can leave our end-to-end in the background, and we can go ahead and create our service. So NestJs service user no spec. It's going to create a service for us that we can now use. Let's put it there. And we need to create a function here, edit user. In the same fashion that we have done with the Auth service. So edit user is going to be probably an async function. It's going to take several fields. It's going to take a user ID. And that's pretty much it. And it also needs to inject Prisma service. And that's about it. So once it receives the user ID, it also needs to receive a DTO, and it's going to be a edit user DTO. Let's create that DTO. So edit user DTO.ts, and it's a class edit user DTO. And what can we edit? Well, we could edit the email, we could edit the first name and the last name. So email string, first name string, and last name string. And all those fields can be optional, because we can just edit the email without editing the first name, or the first name without the email, etc. Right? So we can also provide the class validator is email. This is going to be is string. String is string. And all those are going to be is optional. Is optional, is optional. And we need to export that edit user DTO and export it here through the backend export pattern from edit user DTO. Let's clean those files and come back to user controller. The patch request edit user will receive a body of type edit user DTO, and it's going to also get the user and just the user ID. So ID, user ID, and it's going to be a number. And it's going to call the function in the user service, edit user, and it also needs to have the DTO, edit user DTO. And let's just call that. So on that side, on the controller side, this is done. Return this. We have, of course, not imported the user service here. We also need to import it through dependency injection. Private user service. And now we can use that user service here, return this user service, edit user, user ID, and DTO. On the controller side, it is now done. Let's go back to the user.service and write our logic here. So what we need to do is to update the user with the DTO. We know that the DTO will either have an email, first name or last name, so we can trust the DTO because remember we have this function, we have this pipe with whitelist.true, so we are sure that we are going to receive at least something in our API request, and we can say user is equal await this Prisma user update where ID is user ID, and the data that we're going to update, we just can destructure the DTO. So if the DTO has something, it's going to be destructured here, and before returning the user, we can delete the user.hash and return the user. That's our edit logic. And before continuing any further, let's go back to our test and run the test for that edit functionality. So we come back to our tests. We have, where is that? We have user get me, and we have edit user, right? So we go here and we just copy the test here and write should edit user. It's going to be users, and it's going to be a patch request, and the headers are correct, and we need also a body. The body will have the DTO edit user DTO, and let's just edit the first name Vladimir and just the email vlad@codewithvlad. And let's push that DTO to the body with body DTO. And let's see if we can get something interesting. So first, let's see if this test executes. So here it goes. Should edit user, it is executed. Interesting. And let's maybe inspect that. Where's the answer? Here is this. This is the response. So we get the user with the updated email and with the updated first name, which is quite cool. So that works. We can also make our tests a bit more defined. For instance, we can say that, oh, we expect that the body contains a field, where we expect that the body contains a first name Vladimir and an email of that. Well, we can just say expect body contains, and we can provide a value. So it's going to be dto.firstname, and we can do the same with dto.email. And let's see if our code executes. Cool, our code is now working. Obviously, you can test it out. You can say expect body contains, let's say, I don't know, false value. And that should throw an error because false value is not part of the body. Value false value not found in response body. So that's a handy way of checking if some fields are there without going too much into details. Okay, now let's go ahead and create the routes for the bookmark. So for the bookmark, we haven't done anything yet. We will need to have a controller and a service. Let's go ahead and create those. So NestJ controller bookmark, no spec, and same for the service. Very cool, we can clean that out. And here, what do we need? We need to have a couple of routes. Okay, bookmarks, maybe put it here as bookmarks. We also need to use some guards. So GWT guards, you need to have an access token in order to use those routes. So that is done. Add all missing imports. Have we forgotten something else? No, I think we have it all. We can close user controller and just work with bookmarks controller right now. So we have a route to get all the all the bookmarks. So it's going to be get bookmarks. We also have get bookmark by ID. We have edit bookmark by ID, and maybe delete bookmark by ID. Let's check our test if we haven't forgotten something. Create bookmarks as well. So we get bookmarks, get bookmark by ID, edit bookmark by ID, and delete bookmark by ID. And we also need to have a route for creation. So create bookmark. That's it. We need to have a post decorator for create bookmark. We need to have a get decorator for get bookmark by ID. Let's move it above, so gets are in one place. We also have edit bookmark by ID, so it's going to be patch, and delete is going to be delete. So we have the whole CRUD thing. Let's also import the service, because all our business logic will be in the service. Private bookmark service, and let's copy all those functions in the bookmark service and just clean the decorators here. Here we go. Very well. Now all of them will have to use get user decorator, get user, and it will have to use user ID, number. Sorry, it actually goes into here, and we need to fetch the ID. Same goes for here. Same goes for here, and same goes for there. And the reason why I have to have the user ID is that I can check if a bookmark belongs to a certain user or not. So when we are deleting a bookmark, we need to make sure that we are not deleting the bookmark of someone else. And when we get the bookmarks, we need to make sure that we are getting the bookmark of that user. That's why we need that. So the get bookmark will not need to have a DTO. This will not need to have a DTO either, but it will have to have a param. So if we want to get a bookmark, so get bookmarks by ID, for instance 2 or 5, well, this ID is called a param. We can get it with another decorator here, param, that also comes from Nest command, and it's going to get the ID, and the name of that variable will be equal to the variable that we define here. And we need to put 2 dots like that, and similar to what Express does. Express also has those parameters, and it's going to be bookmark ID. It's going to be a number, and by default this is going to be a string, but we can convert it to a number with parse int pipe. The create bookmark will have to have a DTO, so let's go ahead and create that DTO. Index ts and create bookmark.dto.ts. Export class create bookmark DTO. And what will the create bookmark DTO have? Well, let's check at our schema. So the bookmark has a title, description, which can be empty, and a link. Okay, title, description, and link. Let's go ahead and let's add that. Title is a string, description is a string, and it can be optional, and link is a string as well. And we can use a string validation, a string, and this can be is optional, and this is not empty. Here we go, and we can export that create DTO from the folder. Now we can close it all, open the bookmarks, and add the DTO here as body. The DTO will map to create bookmark DTO, and edit bookmark DTO will also have something similar. And I'm going to show you a cool, neat way to reuse our code. And here we have made an error. It should be capital, and it should be capital here because it's a class, and that should be fixed above. That's nice. And the next thing, we said that we want to have edit bookmark by ID. Okay, edit bookmark .dto.ts. So what we can do is to just copy what we have here, edit bookmark DTO, and everything could be optional. That's the only difference. Here and here. This is for TypeScript to know, this is for the validation to know, so you don't get confused. We can change title, description, and link, and we also need to export that DTO from our DTO folder. And we go back to here, and the patch request will be edit bookmark DTO. Nice. And we just need to have the one last route, delete bookmark by ID. Well, it also will take the ID here, and we can just reuse the same logic that we have in get bookmark by ID. Here we go. We have everything that we need on the controller side. Now let's jump into the service side. Let's jump into bookmark service. So what do we need to get the bookmark? We need to have user ID, which is a number, and that's about it, right? We don't need to have anything else. Yeah, just the user ID. Then we need to get the bookmark by ID. Well, we still need to get the user ID, but we also need to have a bookmark ID, which will be a number. And create bookmark, we need to have the user ID, but we need to have a DTO of create bookmark DTO, since it's going to be an object. Same for edit bookmark DTO dot edit bookmark DTO, and delete bookmark by ID is going to be user ID as well, and bookmark ID, like here. And that's pretty much all our parameters. Now we can pass our values here to the service. Return this bookmark service, get bookmarks, user ID. We also need to do the same here, get bookmark by ID. So just need to change it here, and you also have the bookmark ID that goes there. And for create bookmark, pretty similar, except that the second argument will be a DTO, and here as well it's going to be the same DTO, but it's going to be so create bookmark, edit bookmark by ID. And here we actually have forgotten something. Since it's edit a bookmark by ID, you say the ID of the bookmark at which you want to be edited, and you provide the body. So we have forgotten also to put a ID here. And let's just copy it here. And provide the bookmark ID. And then the DTO. And of course we need to go and modify the signature of that function. And delete the bookmark by ID is going to be return this bookmark service, delete bookmark by ID, user ID, and bookmark ID. Whew, that was a bit tedious, but we have all the logic pretty much programmed from the controller's point of view. Now let's go ahead and jump into the service to see how we can make that work. And we're going to do it one by one. So when you write code, it's also nice to actually test it straight away, so you get an immediate feedback on how your code performs. Here is going to be very wide because we are running end-to-end tests, but usually you would first go with integration tests. But in our case, since the application is quite simple, that's going to do it. We rerun the test database to make sure that everything is updated correctly, all the files are generated as they should be. We have our first tests that are being run, and let's go ahead and add the logic for the second one. So the first thing is to create bookmarks. Okay, maybe we can first get the bookmarks, get empty bookmarks first. Get empty bookmarks. So because we want to kind of simulate the user experience on our app, if we imagine what the user would be with end-to-end tests, let's actually close that, close this to make it a bit more readable. So we have a sign up functionality. The user signs up, then he signs in, then the user will get himself, and then he can edit himself. So we kind of simulate what the user can do on the platform. Then the user will go on a dashboard or something, and he will get empty bookmarks because he hasn't created any bookmarks yet. So let's go ahead and simulate that. Let's copy this code and simulate it here. It should get bookmarks. Return pactum. It's going to be bookmarks. It's going to be a get request. The headers can stay. The body, we don't need any. The status should be 200. And let's inspect the result. And we see that the body is actually empty. Nothing is there. And this is normal because we haven't written any logic yet. So we can come back to our bookmark service and write our logic. So let's import Prisma because it's not imported yet. Prisma service. So get bookmarks. We need to return this Prisma. Sorry, I forgot private. This Prisma bookmark return find many where what? Where user ID is equal to user ID. We can just leave it like that. So it's going to return all bookmarks that are linked to us, to the user that is doing the request. Let's see what it does return. And here now we have an empty array. And because by default, when Prisma will run find many, if it's not going to find anything, it's going to return an array because you are expecting to find a lot of elements, right? So what we could say is that inspect status, expect body, and here we can say what the body will expect, and it should be an array, an empty array. Let's see if that works. Then we can go ahead and continue with our logic, and we can write the code for create a bookmark. So same thing, return it should create bookmark. Return pactum spec post bookmarks with headers correct, and then we need to provide a DTO. So let's go ahead and provide a DTO here at that level. Create bookmark DTO. Okay, the title should be it should be first bookmark, and the link will be, let's actually put a link to one of the videos of freeCodeCamp. I personally like the video of that guy who teaches Kubernetes. Really well done, man. And I'm going to save this URL in my bookmarks. Here we go, and we put the DTO into our with body. It should expect a status of 2 or 1 because it's a post request, and let's see what it does. Well, obviously it will do nothing because we have not programmed the logic yet. So let's go ahead and program the logic. Here it is, create bookmark. So in the same fashion, we can make it async and create our bookmark. Const bookmark is equal, await this Prisma bookmark create data. And what do we put here? First of all, the bookmark is created by a user. So we can say user ID is equal user ID. And then we can just destructure the DTO. And then we can return the bookmark to see what it does. And let's see if our code executes. I'm going to check here and inspect the response. Let's inspect the response. And we see that we have created the first bookmark. It is linked to user ID 9, which is the current ID, and it is the second bookmark. So if we do it again, we see that the ID is 3. It's because while we're cleaning the database, we're not cleaning everything. We just clean the users table and the bookmarks table. There's another table that keeps track of the indexes, and that is not clean, and this is normal that it's going to be incremented. But that's okay, it's not a problem in our case. And anyway, you should not in your test rely to hard-coded IDs like here. So now we have created a bookmark, and we can go here into get bookmark and re-execute the same code. So let's go ahead here, should get bookmarks, and we can just copy it here. And let's see if that code executes. Okay, cool. We have the get bookmarks, and we had that, and we can inspect that. And we'll probably see that we have an array, and in that array there is our newly created bookmark. So now we should have the get bookmarks and expect a status 200, yes, but now we know that the body should be an array and it should be one element inside it. So what we can do to make a very simple test is that expect JSON length to be 1. So we can expect the array of bookmarks should have at least one element. So that's that. We can then proceed and write the logic for getting the bookmark by ID. So the way to do it is to simply should get bookmark by ID, which we will copy the test that we have already. So if we want to get a specific bookmark by ID, we can write it like that, but we don't know the ID, right? We're not sure about it because, as I've just said, we don't reset the IDs that have been sequentially generated by Postgres of our elements. So we need to keep track of the bookmark ID that we have created somewhere. So let's go ahead and where do we create it? Should create bookmark. This is where we need to use the stores API like we have used for user access token. So stores is going to be bookmark ID, and it's going to put the ID field of the bookmark inside it. So to use parameters with Pactum, we need to use their own kind of way of doing so. We need to tell the ID here, and with params, with path params, and it's going to be the key is going to be ID, and the value is going to be the value that we have saved in our store. So let's see if that works. Very well, but now let's write the logic, because we haven't written the logic yet, and we have the function here get bookmark by ID is going to be pretty much the same, apart from we are going to use find first, and we need to get the bookmark that belongs to a certain ID, and which ID is also a bookmark ID provided here. And let's go ahead here, let's execute our logic, and we see that now we have the right answer. And we can go back here and do some basic assertions. We can say expect body contains, and it's going to be, what is it going to be? The value is going to be this number, which is going to be the bookmark ID. Okay, let's see if that works. Perfect. Let's now finish it with edit bookmark by ID and delete bookmark by ID. Before we go any further, let's just examine if everything is correct. Get bookmarks by user ID, that's fine. Get bookmark by ID, yes, that's okay. Create bookmark, we pass the user ID and the DTO, that's fine. And edit bookmark by ID, and this is where we need to do a bit more work. So first of all, we need to get the bookmark by ID, and then we need to check if user owns the bookmark, and then only we are going to do the modifications. So the first part is quite simple. Bookmark is equal await this Prisma bookmark find unique where ID is equal bookmark ID, and then if not bookmark, or so the bookmark at specific ID does not exist, or if the user ID at the bookmark is not equal to the user ID, that means that if the bookmark that we try to edit does not own to the current user, then we throw an exception, throw new forbidden exception, access to resource denied. That's it, and the function should be an async function, and we can clean that out. We don't need those parentheses here because we only have one throw exception, and again it's a guard condition, so it's going to stop the execution of our code below. So if the bookmark belongs to the user, then only we can modify the user, then only we can modify the bookmark. So we will return the modified bookmark, this Prisma bookmark update where ID is equal bookmark ID, and the data will be DTO. We're going to just destructure the DTO here. And we can come back to our tests and just copy our test here. Should edit bookmark by ID, should edit bookmark, and it's going to be a patch bookmarks by ID, yeah, and we need to take a DTO. So the DTO is going to be here, DTO edit bookmark DTO, and we're just going to add the description. And the description was actually we're going to add the title and the description. So let's just copy this. And we pass that DTO to the body with body. Here we expect a status of 200, and let's first execute it and inspect that to make sure that we have the right things. Awesome, we have the right things, and we can just expect the title and description to be of those values. let's, oh, I see that we have a white space here. Let's expect body contains dto.title, and same for dto.description. Let's see our test. Awesome, that works. And now let's run our last test. So usually when you delete a resource, the status that is returned is a 204. Let's see if we can actually do that. So first of all, should delete bookmark. So it's going to be delete with path param ID, yes, with headers correct. We don't need any body. We don't, and let's see if that works. Okay, one thing that I like to use when I delete resources, I like to have the code 204. So we're going to modify it a bit. HTTP code, like we have seen before, HTTP status, no content, which stands for code 204. And if we go back to the test and run them again, we now have an error. We can, of course, go ahead and just modify that. And we can return back to our bookmark service and fill the last logic here. And we don't want to return anything, so it's going to be an async function. Well, here we also need to check if the user owns the bookmark, so we can just copy it here. And if the user owns a bookmark, then we can go ahead and delete it. So await this Prisma bookmark delete where ID is equal bookmark ID. And that's pretty much it. That will delete our bookmark. Let's come back here. And just after the delete, let's make another API request. Should get empty bookmarks. And what we can do is that we can just copy the should get bookmarks here and expect the JSON length to be of 0. Let's come back and run our tests, and yeah, amazing. We now have a end-to-end tested CRUD API with authentication. So I hope that you enjoyed this tutorial, that you have learned something out of it. Of course, there's a lot of stuff that we can still do. We can work on security. When we deploy our API, we can run it in a cluster mode through PM2, and we can do a lot of amazing things with that library called NestJs. Furthermore, to improve the code coverage of this app, we can add integration testing and unit testing. But so far, my mission here is accomplished. I have taught you how to use NestJs and how to make a solid use of its architecture. My name is Vladimir. I hope you liked this tutorial, and see you for more at Code with Vlad.